Okay, can we please look at this question from the Mpumalanga question paper? This is analytical geometry, right? So in the diagram, okay, we are given A, B, and C, and we can see the points of triangle ABC. Point D is shown in the diagram. BD is perpendicular. We can see by that 90 degrees. I'm not going to waste time on explaining that. And then they say that N is the x-intercept of BC. So if N is the x-intercept, the coordinates of N, x-intercept if y is 0. So we don't know the x value, but the y we know that it's 0 for that coordinate of N. Let's answer the following question. If the gradient of BC is 1 over 3 and the gradient of AC is 3, calculate the following. Okay, so the first question, they want you to find the x coordinate of N. And then now, let's say you don't know how to do this, right? Okay, let's say, let me just do something like this. They want the x coordinate of N, and then look at N, where it's N. Why? Look at the if statement. So I'm going to refer on the if statement. What am I given? The gradient. So look at N. It's on the line BC. So N, I'm going to say the point C and B. Those are collinear points. So we know that collinear points are the points that are on the same line. So these are collinear points. So collinear points have equal gradients. So if I'm given BC as 1 over 3, this tells me that the gradient of BC is equals to the gradient of what? I can say the gradient of NC. It's equal to the gradient of NC, right? So which is just 1 over 3. They will have equal gradient. That's the information that I need to use to calculate the x coordinate of N. So I can say that the formula for gradient of NC, the formula for gradient of NC is going to be y2 minus y1 over x2 minus x1, and this is just 1 over 3. So let me write down my coordinates so that you can remember what I'm working on. So I know that my n is going to be x and 0, and then my b, it's c, and then I'm looking for the gradient of c. This is minus 1 and minus 3. Right, let me name my point. Which one is my point 1? Which one is my point 2? Remember, I said that it's best to put your house in order. So C since comes first before N in letters, I'm going to say this is my x1, this is my y1. So this is my x2, this is my y2. It's up to you which point you want to make your first point. Then I'm going to sub in there. I know that y2, which is 0, I'm going to subtract y1, which is minus 3. I have to put it inside the bracket. And everything is divided by x2. That's x, right? Which is the x coordinate of N. And the question says, find the x coordinate of N. This is what we need to find. Then I'm going to subtract x1, which is negative. So I'm going to put that inside the bracket and equate this to 1 over 3. Then from there, you can just solve for x. You can see that on top is just 3, and then on bottom you'll have x plus 1. What is this equals to? 1 over 3. So you can just say 3 is equals to, then you we cross multiply. Let's just cross multiply this. So I'm going to say 3 times 3, that's 9. When I'm cross multiply, that's 9. It's equals to x plus 1 times 1, which is just x plus 1. Okay, then I'm going to say the 1 comes this side, it's 9 minus 1, therefore this gives us x to be equal to 8. That's your final answer. So the x coordinate of that, it's 8. Guys, the reason I'm doing this, the long method, is for me to make sure that you understand everything. But in an exam, you don't have much space to write all these steps, okay? So, right. So now this is how you answer that 2 marks. And then the next question, they say that for 5 marks, they want you to find the coordinates of the size of ACB. So if you don't know which angles are they referring to, you're going to move from A to C. So you're going to draw a line from A is that side, to C. Then you draw another line from what? They say A angle CP. Then you're going to draw a line from C to B. The angle that is between those lines is the one that they are looking for. So I'm just going to name my angle maybe alpha. So they are looking for that angle. This is the angle that we need to calculate. Right. So now this is how I'm going to calculate this angle. And then now let's do this. To find that angle, I know that I can calculate this theta as is the angle of inclination, right? This will be the angle of inclination, and I'm going to call this theta 1. That's the angle of inclination. I can find that. Then I'm going to use angles on a straight line to find that angle, and I'm going to call that angle theta 2. Then now I can form another angle of inclination here, right? Another angle of inclination, let's call that theta 3. Okay, I'm not sure if you guys can see that, but let me just try and write this. Right, so this will be angle theta 3, which will be angle of inclination. Then I note that when I use vertical opposite angles, this angle also will be equal to angle theta 3. So now I'll have angles in this triangle, triangle ONC. Then I can use the sum of angles to find that angle. So let's take that step by step. Okay, so first thing first, already I need the gradient of what? I need the gradient of AC to find theta 1, which is the angle of inclination. Remember, let me write this down. I'm going to say, to find for this question, what is the question? This is question 2.1.2. So to answer question 2.1.2, for 2.1.2, I need to say the tan of theta 1, which is what I'm looking for. It should be equal to the gradient of AC. That's how you find the angle of inclination. And the gradient of AC on the if statement, it was given as 3. So I'm going to sub in that 3 there and say my theta 1 is equal to 3. Then you're going to say, therefore, theta 1 is equal to the tan inverse of that 3 when you isolate theta 1. Then you punch that on the calculator and see what you get. Shift the tan inverse of 3. And this gives us a massive angle, which is 71.57 if I round it off. But I'm not going to round off any angle. So I'm just going to write 71.565 ... I only have to write the final answer. So this will be 71. We said this is 71.565 and so on. So I'm not going to round it off. Right. So since I have this, looking at that, I have theta 1, and theta 1, we are saying that theta 1 is what? What is theta 1 equals to? That is 71.565 and so on. Then I'll go to the calculator to find theta 2. Theta 2, it will be 180 degrees you minus theta 1, which is 71.565 and so on. Then you give them a reason, angles on a straight line. Angles on a straight line. Right, you give them that reason. Then I'll go back to my calculator. Since I have that on the calculator, I just have to say 180 minus answer. So we avoid rounding off. So if I say 180 minus answer, that gives us 108.43. So it's going to be 108.43. If you round it off, it's just 43, né? So 108.43. That's theta 2. So my theta 2, that's 108.43 degrees. Right, I'm going to write it down here, 108.43 degrees. Now, what is the aim now? Is to find theta 3. You see, we're almost close to getting that answer that we are looking for. To find theta 3, I'm going to use the gradient because theta is the angle of inclination for what? BC. So I need to say the tan of that theta 3, it will be the gradient of BC, and I think we do have the gradient of BC. We can see that the gradient of BC is 1 over 3. So I'm going to say that from the if statement, the gradient of BC is 1 over 3. This tells me that the tan of theta 3 is equals to 1 over 3. Therefore, what is theta 3 equal to? The tan inverse of that 1 over 3. So if this is the tan inverse of that 1 over 3, what's next? I am just going to punch that on the calculator. I'm going to say the tan inverse of that 1 over 3. You just have to follow the steps and you'll see that this is very easy. Let me see, this is equals to 18.43. So I'm going to write down that as 18.43 and I'm not going to round it off. So angle theta 3 is equal to 18.43 blah blah blah, and then now this is my 18.43 blah blah blah. Okay, how do we find alpha, the last part? So I'm going to say that in triangle C, okay, let's say O and C, in triangle O and C, alpha is equals to 180. We subtract the sum of those two angles, which is 108.43. We add that with 18.43 blah blah blah. Okay, so what is alpha equals to when you punch that on the calculator? So I still have that as the answer, the 18. So I'm just going to say 180 minus, then I'm going to minus that 108.43, 108.43 plus answer. That answer is the 18.43. Close the bracket, and this gives us the angle that they are looking for as 53.14 if we round it off to 2 decimal places. Okay, so alpha is 53.14. Guys, if you really like the strategy that I used on solving this, guys, I need to see your comments on the section. Tell me what you think about the strategy. If you have another way, just try to tell me what you the method that you think we can use. There is another method. There is definitely another method that you can use, but the one that I'm thinking about is a very, very long method. Ne? The one that I'm thinking about is a very long method, and I really don't want to talk about that method. Trust me, I don't want to talk about that method, but it's fine. Okay, so now the next question says that determine the equation of AC, and this is 2 marks. So looking at the question, where is AC? Oh, this is easy. We have everything on AC. We know the gradient of AC is 3. We can just substitute. You see, the gradient of AC is 3. And when they say determine the equation of AC, to answer this 2.2, we know that this should be in the form of Y is equals to mx plus c. So the gradient is just 3. It's given as 3. Then we can choose any point between C and A to substitute here. So I'm just going to substitute C, which has the coordinate -1 and -3. So this is my x, this is my y. Where there's y, I put -3. Where there's x, I put -1. The aim is to find C. So this is -3, it's equals to 3. Okay, it's -3, it's equal to -3 plus C. So if the -3 goes to the other side, that will be -3 plus 3, which gives us the value of C to be 0. And if the value of C is to be 0, what is the equation of AC? The equation of AC is Y is equal to 3x plus C, which is 0. So it's just 3x. That was easy. So now the next question, they say, it is further given that the point D lies on AC is produced such that BC is perpendicular to BD. Okay, let me take this slow. It is further given that point D lies on AC. Let's go and make that. They say that this point D, it lies on this line AC. Okay, so D should be on that AC. I'm just gonna put it like that, right? So this is what we have. Okay, this is wonderful. This is wonderful. And then now they say that such that BC is perpendicular to BD. So we can see that this line BC. Okay, let me look at this. BC. Okay, my BC is perpendicular to BD, which is that part here. They are perpendicular. We can see that. All right. So now the question says, calculate the coordinates of D. Okay, let me explain this, how to find the coordinates of D. Look at this point here. This is what we call the point of contact, the point of intersection. How do we find the point of intersection in maths? We equate the equation of the two lines. So I need to find the equation of AC. Am I right? Yes, I need the equation of AC. I need to find the equation of AC, equate that to the equation of BD. Then after equating the equation of those two, I can just find the x value there, and then I can use one of the equation to find the corresponding y value. So now, when I look back to the previous questions, I know what is the equation of AC. That's 3x. So the equation of AC, I know that the equation of AC, that's 3x. I need to equate that with the equation of BD. Do we have the equation of BD? No. We need to first calculate the equation of BD. And then now they said that BD is perpendicular to BC. What do you know about lines that are perpendicular? What can you tell me about their gradients? So if two lines are perpendicular, the gradient of BC multiplied by the gradient of BD, they should give us -1. Okay, so now this tells me that what I'm going to do from this point, I have the gradient of BC. It was given as 1/3. So the gradient of BC is 1/3. We multiply that by BD, we get -1. So this tells you that in conclusion, the gradient of BD, it will be what? The gradient of BD is going to be 3 without is the reciprocal of 1/3. So the gradient of BD should just be -3. I hope you guys understand how we got that one. We just multiplied both sides by 3 to get rid of that 1/3. To get rid of that 1/3, you multiply both sides by that 1/3. Let me also put that in writing. So we are multiplying this side by 3, this side by 3, so that we can get rid of that 1/3, and then we are left with BD, which is -3. So now that you have the gradient of BD, we are looking for the equation of BD. We can use B because this is the only point that we have on that BD, and we can use that point 11 and 1 to find the equation. So I'm going to work out on that question right now. Let me just do it down here. So I'm going to say that y is equals to mx plus c. Y is equal to, substitute the gradient plus c, then you choose point. We said we're going to substitute point B, which is 11:1. Let me quickly confirm that is 11 and 1. So this is my x, this is my y. So from this equation, I'm going to have y as 1. It's equal to -3 into 11 plus c. Then 11 times 3, that's 11 times 3, that's 33, right? So it's going to be 33. This will be 1 is equal to -33 plus c. Therefore, what is c if you bring the 33 to the other side? The value of c is just 34. So now this gives us the equation of BD to be equals to -3x plus c, which is 34. -3x plus 34. So now you have the equation of BD. If you understand how we got the equation of BD, you just have to go and sub in this BD on that part that we were working on. We said the equation of A we sub in that with the equation of BD, which is 3x, it was minus 3x plus 34. Okay, let me just confirm, minus 3x plus 34, that's correct. Then you solve for x. So the 3x goes to the other side. This will give us 6x. It's equal to 34. Divide both sides by 6. Divide by 6. Therefore, what is the x value of D? Remember, when you do the point of contact, when you are equating the two equations, this will give you the x value of D. So the x value of D, we just have to punch that on the calculator. See what is 34 divided by 6. This is 17 over 3. So I'm going to say x, that's 17 over 3. Then I need to find the corresponding y value. So it's up to you which equation you want to use. You can use any equation. If you use equation AC, we know that equation AC is 3x. Y is equal to 3x. Therefore, to find the y value will be y is equal to 3. Where there's x, we put that 17 over 3. And then you punch that on the calculator. But we can see that the 3 will cancel, which gives us y to be just 17. So the coordinates of D, will be 17 over 3 is to 17. 70. So now, before we enter this one, let's assume that maybe you prefer to use, remember we used equation C to find the corresponding y value. We can also use equation BD. So if you use equation BD, your y will be minus 3x plus 34. Then your y will be minus 3 into where there's x, I'm going to put that 17 over 3. Then what is that equals to? It's minus 3 into x, 17 over 3. Then we're going to add 34. Okay, looking at this, the 3 cancels. This leaves me with y is equals to minus 17 plus 34. I hope that it's 17. Please give me 17 so that I can end this one. We have minus 17 where we add 34. Please give me 17 now. So the y value is 17. So it's up to you which point you want to use, which gives us D to be 17 over 3. And the y value is just 17. Those are the coordinates of G. And that's how you answer this question. I think this was a very nice question. Yeah, I think this was a very nice one. And that's it for this one. So let's look at this one. Okay, so on this one, the total number of red countries issued per country of a player during a soccer competition are given in the table below. We can see the table. Let's go through the table. They say the number of red cards. The country that got 0 to 2, there are 27 countries. 2 to 4, there are 15. 4 to 6, there are 5. 6 to 8, there are 5. 8 to 10, there are 3. So now they want you to find the estimated mean of the number of reds per country, red cards per country. Okay, so now what I'm going to do, I already have the formula for mean here. We're going to find the sum of f times x over n. So this n is the number of countries, which is your frequency, the sum of your frequency. So I'm going to first find the total for that. I'm going to take the 27. Let's add that with 15. We add 5 plus 5 plus 3. So this gives us 55. So the total is 55. So that block there will be 55. So now, in order for you to find the midpoint it's like you still remember what you were doing when you do the midpoint, x1 plus x2 divided by 2. So this is what we're going to do. 0 plus 2, that's 2. Divide by 2, we get 1. Then you write 1 there. Then 2, you add 2 with 4. That's 6. Divide by 2, 3. Then you say 4 plus 6, that's 10. Divide that by 2, we get 5. Then 6 and 8, that's 14. Divide by 2, we get 7. 8 plus 10, that's 18. Divide by 2, we get 9. Okay, so now I know that the midpoint, we're not going to use the total anywhere, so I'm just going to move to f times x. So f times x, this is your f, this is your x. You just have to multiply the two. 27 times 1, 27. 15 times 3, that's 45. Then you're going to say 5 times 5, that's 25. Then what's next? 5 times 7, that's 35. We are multiplying 3 with 9. So that's 9, 18, 27. So this will be 27. Then we need to find the sum for those f times x. Né? So let's quickly work on that. So this will be 27. We added that with 45. We added that with 25. We added that with 35 and plus 27. This gives us an answer of 159. So this will be 159. Okay, let's answer the question now. So to calculate the estimated mean, we said it will be the sum of that f times x divided by the number of n, which is the number of countries, so which is the frequency. So the mean, to calculate the mean, the estimated mean, you're going to take your 159, you divide that by your 55 that you got. Therefore, the answer that you get, it should be your estimated mean. So the estimated mean, this one, it will be equals to, let's use the calculator to say 159. I'm just going to divide the answer by 55. So this gives us approximately 2.89 if we round it off. So which we're going to say the estimated mean, guys, when 2.89, let me explain the weight estimated. Estimated, you don't write 2.9. So you're going to say the estimated mean is estimated mean, you round that to the nearest number. So you are estimating the mean. So approximately this is 3 red cards. So this will be 3 red cards. I hope you understand that part. 1.2, draw an OGIF cap to represent the data, the above data. So to draw an OGIF cap, we're going to need a space for that. And I'll definitely work with you on that one, okay? So let's go and draw the OGIF curve using the information that we have so far. Okay, so now I think this will be easy when you do it in your exam book, because remember, you'll be given the space to draw that. They will bring this in, it will be drawn to scale, right? So this is 60. Let me say this is my 50. 40, should we say 60, 50? Okay, 60, 50, 30. Then this will be 20. Then it's 20, 30, 40, 50, 60, then 10. Then we start at 0. Right, so this side, we always know that the y, we put the cumulative frequency. So this is the cumulative frequency. So this tells you that we need to go back on that whatever that we were doing to find our cumulative frequency. We need to go back and find the cumulative frequency. So this side, this will be your interval, right? Which is the number of red cards. So this will be the number. This side is going to be the number of red cards. Right, so now let's quickly put in the number of red cards. It's either when you put this, guys, let's go back. You put the last numbers on your interval: 4, 2, 4, 6, 8, 10. Those are the numbers that you need to put. So we start at 2, 4, 6, 8, 10. Then now when we plot, we need to find the cumulative frequency, which is something they did not include on that table, but I'll definitely help you guys how to find the cumulative frequency. So let's work on that. So the cumulative frequency should be next to the frequency, okay? So maybe somewhere here, I'm going to create another column for cumulative frequency. So this is for cumulative frequency. I think you can see what I'm trying to do here. For cumulative frequency. So I'm just going to try and say this is cumulative. So you can see that. So the cumulative frequency, this is how it starts. You take the first column, the first number, you just move it this side, which will be 27. Then to find the next one, you add 15 with 27 and see what you get. Okay, so you add 15, going to say 15, we add that with 27, this gives us 42. So the next one is 42. Then the total now is 42. You add the next number on the number of counters on the frequency column. The next number is 5. You're going to add 5 to that 42. So you're going to say 42 plus 5, which gives us 47. The next one is 47. Then you add, the total is 47. We add the next number on the frequency column, which is 5. So this will be plus 5. And then the next one, this gives us 52. I'm going to put my 52 here. From 52, we add 3. That gives us 55, if I'm not mistaken. Yes, that will give us 55. Okay, so I'm just gonna write this down here and say the last one is 55. So now let's talk about plotting the OGIF graph. The first point, it will be that 2 and 27. Let's go and plot that point. So it's 2, which is this part, and it was 27. 27 is somewhere there before 30. So it will be somewhere at this point there. So I'm just gonna put it there. And then the next point is this one. It's going to be 4 and 42. Okay, the next point is 4. This will be my 4. And 42, I know it's somewhere right there. This is 42. Okay, and 4. So this will be 42 and 4. Remember, you'll have this on the answer book, and for sure yours will be drawn to scale. Now, the next point, it's 6. This is 6 and 47. 6 and 47 is somewhere there before 50. So it should be somewhere at this point, all the way to that point. Right, let's go and determine the not the last, 8 and 52. Okay, so 8 and 52. 52 is somewhere there. Okay, 52 and 8. So 52 and 8. So this will be the point there. Okay, and then the last one, that will be 10. It goes with 55. 10 goes with 55. So 55, it's exactly at this point here, and it's somewhere here. Okay, 52 and 10. Then the last thing you need to do is to connect your dots. But the most important thing, remember, on OGIF, you should start at 0. So we start at 0 and 0. Then you're going to connect your dots. You're going to connect your dots to have your OGIF graph. I hope you understand how we did that graph, then. Right. Let's see the next question. The next question says that was 3 marks. The next question for 2 marks, calculate the interquartile range. So when they want the interquartile range, the formula for interquartile range, it's equals to the upper quartile, which is Q3, you minus the lower quartile, which is Q1, and we need to use the graph to find those guys. So I need to first calculate Q3 and Q1 first. Then I'll find the difference of the two. So look at this. To answer this question, 1.3. To answer that 1.3, I need you to always remember this following formulas. Okay, so Q3. Okay, let's start with Q2. Q1. Q1 is your lower quartile. Right, and the lower quartile, the formula for the lower quartile goes like this. So Q1 is equals to, we take n, we add 1. The answer that you get, you divide by 4. So this will give us the position. Let's go and find this. Remember, n is the number of frequency, which was 55. Né? So this will be 55. Q1 will be 55 plus 1 divided by 4. So that is your lower quartile. You just have to punch that on the calculator, see what you get. So this will be 55. You add 1, then this is equal to 56 divided by 4. This gives us 14. So the position is 14. The position is 14. So this will be 14. So let me tell you something. This 14 is on your cumulative frequency. You're going to go to your cumulative frequency. So this is on cumulative frequency. You're going to go on that cumulative frequency where there's 14. You're going to take your ruler and say, I know that 14 is somewhere here. And then you're going to connect you're going to connect your ruler like this. You connect your ruler, you go like this. Then where you reach the graph, you start going down. So you don't have to stress about, hey, how will I know that my answer is accurate? Remember, in an exam, you'll be given an answer book. So your graph will be like nice and neat. So this tells us that Q1 is just 1. So I'm going to write down and say, therefore, my Q1 is equals to 1. Now, what is the next step? Is to find Q3. Q3 is your upper. This one will be your upper quartile. Right, and the formula for this one, you just say, whatever that we did to that side, the difference with this one is just, this one will be 3 into n plus 1, everything divided by that 4. So you just say 3 into, so this will be 3 into n. This will be 3 into n, which was 55, you add 1. Close the bracket, this gives us 168, divide that by 4, this gives us 42. So this tells you that the position, this was 3 into 55 plus 1 divided by 4. So the position is 42. You go to your cumulative frequency, you point out where there's 42. 42 is at the exact point as that one, the one that we created, if you still remember, is at the exact point of that point. This point is 42. So it will be the same as that one. And we know that that point was pairing with what? With 4. So if I go and say it is at 42, this will be my Q3. I go down, this goes straight to 4. So my Q3 is 4. Therefore, I'll have Q3 to be equals to 4. Therefore, remember, when they want the interquartile range, the question said, calculate the interquartile range. So the interquartile range is the difference between Q3 and Q1. So my Q3 is equals to 4 and minus Q1, which is 1. Therefore, the interquartile range is 3. Give them that answer, you definitely collect your marks. So this tells you that the question said the interquartile range of rate cards issued per country. So it's going to be 3 rate cards. And that's it for this one. So I think you can see how easy it is to collect that 8 marks. Okay, let's look at this one. Let's see what we have on this one. This is question 7 of Northwest question paper. In the diagram below, O is the center of the circle ABCD. A point on the semicircle such that ABCD is a rectangle. So if this is a rectangle, we know that the line of that rectangle, it will be perpendicular to the radius, which makes this to be 90. This one also to be 90. Okay, so ABO and OCD, those are your right angle triangles. So the radius of the semicircle is 6 units. Okay, so if the radius is 6 units, so OC, which is the radius, this line, it's equal to that line, because also BO is the radius, because it's line from center to the circumference. So this will also be 6. And they say the angle COD is theta. We can see that an AO and OD are equal. First question. Write BOC in terms of theta. BOC in terms of theta. So let me quickly indicate which angle are they referring to. So if you want to understand the angle, you start from B, and then you're going to draw a line from B to O, right? A line from B to O. You move from B to O, then from O, you move to C. Then this is the angle that is between those two lines, is the angle that they are referring to. So this is the angle that they want us to find. So I'm not sure if you know that if I have a rectangle like this, we know that if I have a rectangle like this and I draw the midpoint of a rectangle, so if this is my A, B, the midpoint of that rectangle, when I say this side is equal to this side, then I draw a diagonal from this point to that midpoint, another diagonal from this point to that midpoint. I'm going to have by symmetry, this angle here, it will be equal to that angle by symmetry. So this tells you that this angle here is theta. So that's what I'm going to first tell the marker. I'm going to tell the marker that BOA, angle BOA, that it's equal to theta. And if this is equal to theta, the angle that they are looking for, can you see that we can use angles in a straight line to find that angle? So angles in a straight line end up to what? They end up to 180 degrees when you add them. So I'm going to say, therefore, I know that I'm going to name this angle that they are looking for. I'm going to let this to be X. So I'm going to let that angle to be X and tell the marker that if I take all those angles and add them, they should give me 180. Then you'll tell the marker that this is angles on a straight line. Okay, so now this will be 2 theta plus X. We are looking for X, right? It's 180, and we need to write that X in terms of theta. Therefore, what is X? X will be 180 degrees minus that 2 theta. And we know that this X is what? Is BO, it's B angle OC. I hope you understand how we did that one. That was easy 2 marks to get. Okay, let me move to the next one and see what I can do from that next question. Next question says that if theta is 43 degrees, calculate the length of BC. Okay, let me go and look at my BC. This is BC. This is my length BC. So this is good because already if I have this length, this angle, and which is opposite to the side that I'm looking for, I can use what we call the cosine rule to find that angle. So remember, the cosine rule says that if we are looking for BC, so BC squared is going to be the sum of that the other 2 angles. So what I'm trying to say, not the sum of other 2 angles, but the sum of other 2 sides. So I haven't included angle, then I will add the side that gives me that included angle, which is BO and OC. I'm going to say this again. When you use the cosine rule and they want you to find BC, so BC will be equal, BC squared will be equal to, you first add the side that gives you that excluded angle, which is BO, so this will be BO squared plus OC squared. Then after, you have to subtract 2 times the product of those sides, which is BO multiplied by OC. Then this will be the cos of that included angle, the cos of the included angle, which is angle X. Then now you can just do the substitution. But remember, and we need to first find angle X if theta is 43 degrees. Let's quickly work on that. So I have theta as 43 degrees. I have to first find what is X. Remember, we said that X, this angle X here, we just said X is 180 degrees minus 2 theta. And now we are given theta. This will be 180 with minus 2 into 43 degrees. So I'm going to punch that on the calculator and see what is my X. So I'm just going to quickly punch this on the calculator, say 180. I'm going to subtract 2 times 43 and see what is that equals to. This gives us 94 degrees, right? So angle X is 94 degrees. So on that formula where there's X, we're going to sub in 94 degrees. So now let's do the substitution and see what we get when we substitute on that. What will be BC? So BC squared will be BO is 6. So this will be 6 squared plus also OC is a radius, that's 6 minus 2 into 6 into 6, the cos of 94 degrees. So I'm going to just punch everything there on the calculator and see what is that equals to. Wow, I'm having so much fun. This is an easy question, eh? 6 squared plus 6 squared plus 6 squared minus 2 into 6. And then we have into 6 again, the cos of 94. Right, I'm having so much fun. And if you are also, this is 77.022 next. If you are also having fun, please make sure that you follow the channel, subscribe to the channel so that you don't miss the next lesson. So the answer is 77.0224 and so on. Therefore, I need to square both sides to find my BC. So BC will be equals to, I'll go to my calculator and say the square root of answer. And say the square root of answer, that's 8.78 if you round it off, 8.78 units. That's BC. So BC will be 8.78 units. 8.78 units. Easy question. Right. Okay, so now on the last question, this is 4 marks. Let's look at what we have here. 7.3, it says that points A, B, C, and D are shifted along the semicircle. They want you to calculate the value of theta if A, B, C, D now forms a square. Guys, okay, let me explain why they are telling you that A, B, C, D forms a square. So I need you to think about this. What will happen if A, B, C, D forms a square? So I'm going to write down A. This is my A, this is my B, this is my C, and this is my D. So I have a point like this, and we know the properties of square, right? All sides are equal. All sides are equal. Therefore, if this forms a square, this tells me that AD, the line AD, it will be equals to what? The line AD is equals to DC. Okay, so the line AD is equal to DC. So they want us to do what? They want us to calculate theta, which is this theta. So to calculate this theta, I can use this side as my opposite, and then I can use this side as my adjacent, because this is a right angle triangle. So this is my Y, this is my X. So now the most important thing that you need to understand is that we are working with what? We are working with a square. And if we are working with a square, this tells you that my diagonals now, it will be AD. My diagonal, my adjacent will be AD. So look at my diagonal. So it will be AB. Then if this is AB, then I'm going to write this like this. So this tells you now this time AD, okay, let's say the line GC, or let's say OD. look at this. Let me just write this down. The line DC is going to be equals to, because now remember, we are saying that we are forming a square. This will make DC, we know that DC is equals to what? DC is equals to AD. But now remember, AD is the sum of AO and OD. And they are equal. So this tells you that DC will be 2 times AO or OD. So you can say DC will be 2 times OD. This is where everything starts to be like more confusing. But if you really understand this, let's work on this. Let me try to explain this. So I'm saying that if A, B, C, D becomes a square, this side is going to be equal to that side, right? But remember, AD is the sum of, okay, let me write this down. AD, it's equals to the line AD. The line AD, which is from this point to that point, it's equals to the sum of AO plus OD. But AO and OD are equal, so I can just add this and say AD, instead of saying AO, I can say it's OD plus OD. OD plus OD, which makes AD to be 2 times OD. And we are saying that AD and DC are equal. So what is DC now? DC is 2OD. I think now you understand what's going on. And if we need data, I'm going to say that in that triangle, I'm going to say that in that triangle, in triangle ODC. So I'm going to write down for the marker to understand which triangle I'm working on. In triangle ODC, then I'm going to say that the theta, look at what I have. I can use my opposite because I have OD. I know what is DC. And then, yeah, I'm going to say OD over, I have opposite and adjacent. So according to SOHCAHTOA, I have opposite and adjacent, that will be the tan. So I'm going to use tan theta. This will be the tan of that angle. It's equal to tan theta, that's opposite. And what is your opposite? DC over adjacent. What is your adjacent? Remember, your adjacent is OD. Okay? Your adjacent is OD. In that triangle ODC. Then now I just have to substitute. I just have to sub in. This will be the tan of theta. It's equal to DC. We set DC, it will be 2 times OD. Okay, so this is 2 of OD over OD. Therefore, the OD cancels. I'm left with the tan of theta to be 2. I can find the tan inverse of that. So theta will be equal to the tan inverse of that 2. You just have to go to your calculator and say tan inverse and see what you get. I shift the tan of 2. That's equals to 63.43. So the tan inverse of that 2 is 63.43. Okay, so when you round it off, it's 63.43. So that's theta. So theta is equal to 63.43. So the most important thing for you to understand is that if ABC is now a square, this line, which is AD, it will be equal to DC. So now, since they are equal, we know that AD will be the sum of these two. Since it's a midpoint, all the other sides are equal, then use that to find AD. AD is 2 times OD, but we know that AD is equal to DC. So I need you to try pause the lesson and try to make this work. Try to practice the question, and until you get it right. And that's it for this one. Okay, grade 12. On this lesson, I want us to continue with this question paper. Remember, on the previous lesson, we worked on question 1 of this question paper, which was analytical geometry, and we also did question 2. Right, I'm gonna put in the description, the link on the description. So I'm going to put the link on the description so that you can go and look at how we answered those other questions. So we stopped at 3.2. We did 3.2 on that lesson. Now on this one, I need to start on 3.3 going down. Let me work on that. Okay, so looking at 3.3, they say that if tan is equal to 4 over 3, where a is an element of 90 and 360. Use the sketch to determine the following. So I'm going to work on that 3.3 on this paper here. Okay, so first thing first, what are you given? That's what you need to ask yourself. What are you given and what they want you to do to solve? But I'm just going to first focus on that tan is equal to 4 over 3. So this is the first thing that I'm going to write. So we are given that okay, let me do this. Okay, so you are given that the tan, which is 4 over 3, the tan A, it's equals to 4 over 3. And when I look at this, and they say that A, it's an element of 90 and all the way to 360. Right, so let me draw the diagram and see where is the quadrant that we need to work on. Which quadrant? So if this is 0 degrees, this is 90, I'll have that as 180 to 70 degrees. Okay, so 90 going that side. I'm gonna put a tick in that quadrant, a tick in this quadrant, a tick in that quadrant. This is for that diagram, okay, for the interval. So it will be quadrant 2, quadrant 3, quadrant 4, but not in quadrant 1. Then look at this. The tan of theta, what can you say about the tan? The tan theta, the tan A is greater than 0, meaning it is positive. We need to take the quadrants where tan is positive, this quadrant and that quadrant. So the quadrant that has 2 ticks is where you need to draw your diagram. Okay, so my diagram will look like this. This will be my diagram then, and this will be my points here. But now I need to form something like a right angle triangle in that diagram, and this will be my angle A. Right, so this is my angle A. So now if you look at this, according to SOHCAHTOA, tan is opposite all over adjacent. So the tan of theta, it's equals to opposite over adjacent, which is y over x. So this tells me that this is y over x. We have y, we have x, we need to find r. That's how easy the question is. You need to find r, and when you find r, look at this. My x is 4. Okay, my x is 4, but this is not making sense, guys. Let me go back to the question. Maybe I'm missing something. 4 over 3, but this is a quadrant 3. Let's think about this. Think about it. So the y values are negative in quadrant 3. So this is minus 4, and the x values are also negative. So this is minus 3. Now it makes sense because it's the same as saying the tan of A is like saying the tan A is minus 4 over minus 3. So the negative cancels. So I think they are trying to play with your mind here. Please don't fall for that trap. Now, please make sure that you open your eyes, and then when you substitute this, it's minus 4, not 4. So the negative cancels, but they don't put the negatives there just to see if you know that in quadrant 3, the y and the x values are negative. Okay, so now we need to use the theorem of Pythagoras, okay, to find r. So r squared is equal to x squared plus y squared. Now let's just substitute. So r squared is equal to x, which is minus 3 squared, plus y, which is minus 4 squared. Therefore, r squared is 25, because that's 9 plus 16, right? That's 25. You square both sides. This is the radius. It's always positive. So r is 5. That's your R. So R is 5. I'm just going to write it there. Let's go back and see what is the question saying. If this, use the diagram to determine the following. The sign A. Now we can find sign A. Okay. What will be the sign A? So if I'm looking for sign of A, sign its opposite all over hypotenuse. My opposite is the y value, which is -4, over hypotenuse, which is 5. That's the sign of A. It's -4 over 5. Let's answer the next one. The next question, 3.3.2, they want the cos A plus 30. So we are adding two angles. What comes in your mind? The cos A plus 30, at least. I'm adding two angles. What comes in your mind? Should we double? Let's duplicate this step now. If you look at this, we are adding two angles. What comes in my mind is compound angle. So look at this. It's the compound angle for cos, because it's a cos of plus, né? So the formula it will be this one. We are adding two angles, so we can expand that and write it as the cos alpha times the cos beta minus the sine alpha times the sine beta. So that's what I'm going to apply there. I'm going to change this guy. I'm going to write this as the compound angle, which is the cos of A, multiplied by that cos of 30 degrees. And then I'm going to add, since it's positive, the sign changes to negative. You don't have to stress. Just go to your formula sheet, copy down that formula, né? And then this will be minus the sine A and the sine 30. Right. So now this tells you that we need to find the cos A. Remember, cos is adjacent. The cos A, it will be adjacent over hypotenuse. So adjacent is -3, hypotenuse is 5. So this will be -3 over 5. So where there's cos A, I substitute -3 over 5. So this will be -3, everything divided by 5, times the cos 30. You just have to use your calculator on that, né? So when you say cos 30 on your calculator, this gives us √3 over 2. We minus the sine A, it's what we calculated on the previous question. It's -4 over 5. -4 over 5, and then the sine 30, that's half. Right, so now when I work this thing out, I'm just going to multiply the top part first. What do I get? It's -3 times the √3, which is -3, √3 over 5 times 2, that's 10. Then minus 4 times 1, that's -4. When you do that, when you add the 2, when you multiply the 2, what do you get? So it's like saying minus into, okay, -4 times 1, that's -4. And then over 10. So basically this will be positive because the negative will cancel, which gives us 4 over 10. Right, so now the denominators are the same. I think we can write this in this form and say, what will this be equals to? So if we write this in the form, it will be, okay, we can write this as 4, then we subtract that 3, √3 over 10. Because if I have A over B plus C over B, since the denominators are the same, I can write this as one fraction. Then I add the numerators. Okay, and I think that's it for that question. Let's move to the next one. 3.4. So on 3.4, given the cos 12 is equal to P, with the aid of the diagram, determine the following without using a calculator in terms of P. Okay, without using a calculator in terms of P, and we are given the cos 12 is equal to P. So this one is different. The difference between this one, you were given a number there, but this time it's just a variable. So let me show you how to use the aid of the diagram. If whatever that you are given, it's given to you as a variable. First thing first, I need you to draw the diagram. And this is how you draw the diagram. Okay, so you are given the cos 12 to be equals to P. So we are given the cos 12. This is the cos 12 to be equals to P. Okay, let me go and look at that question. Okay, the cos 12 is equal to P. So I'm going to let that P to be over 1. So this will be P over 1, right? So if it's P over 1, I know that cos is adjacent over hypotenuse. So I have X, I have R, and then where is 12 degrees? That's in quadrant 1. So my diagram will be in quadrant 1 because angle 12 degrees is in quadrant 1. So my diagram will be in quadrant 1. This is my diagram. And then this will be my angle, which is 12 degrees. This will be 90. Okay, so now what's next? Now what I'm going to do from this step, I just want to use the theorem of Pythagoras. R squared is equals to x squared plus y squared because I need the missing number. So my R is 1. So this will be 1 squared. It's equals to x, that's P. So this will be P squared plus y squared, which is what we are looking for. So 1 minus P squared, it's y squared because the P goes to the other side. What do you get when you square root? Plus or minus the root of 1 minus P squared. So that's why. Now we need to decide it's y positive or negative. How do we do that? Look at this. The y values, remember, these are the y-axis. This is your x. So the y values are positive. Therefore, y will be positive the root of 1 minus P squared. And that's it for that one. So now you can start answering the questions because once you have all the values y, x, and y, and r, that's when you can start answering. They wanted the sine of 78 degrees. So let me write this down. Sine 78 degrees, okay? And we need to use this diagram. So if this is sine 78 degrees, I'm going to check if I can't reduce that 78 degrees to what? Can we reduce that 78 to at least that 12 degrees? Let's check if this is possible now. So I'm going to use my calculator to check if this is possible. Let me check. I'm gonna say 90 minus 78 and see what I get when I do the 2. So it's gonna be 90. Let's minus that 78. Look at the answer, 12. So this tells you that we can write this as, we can write this equation and say this is the sine of 90 degrees minus 12. Because we know that 90 minus 12 is 78. Therefore, where is 90 minus? Because if I have a Cartesian plane like this, and this is 90 degrees, so 90 minus goes in that direction. You understand? Because I'm approaching 0 when I subtract from 90. So it's in quadrant 1. How is sine in quadrant 1? Sine is positive. So this changes into what? Positive the cos of that 12 degrees, which is what it was given. They said the cos 12 is P, and that's your answer. That's how you collect the mark. Then you move to the next one. Let's look at what we have on the next one. So the next one is the sine 6. How are we going to work with this one? I think it has to do with double angles, right? If I think about about this, how can I create 12 from that 6? Because if I'm given the sine, what is this? Let me go back and check. Sine 6. Okay, so if I have the sine of 6 degrees, oh boy, how can I create the sine 6 without making a mess? Let's think about this now. So I think what I'm going to do when I have this, look at this. I already know what is the cos 12. Now, so let me bring that back. I know that the cos 12 degrees, it's something that we can write as the cos of 2 times the 6, because that will give us 12. This will make sense. You'll understand why I need us to write it like this. So first thing first, remember the identities. How are the identities going? So the identities, they work like this. Identities, they work like this. For double angle, this is the cos of 2 theta. We can write that as 1 minus 2 the sine squared theta. That's the only identity that I'm interested with, because if I change this guy here, this will be where there's theta. Okay, let's say this is my theta. Where there's theta on this formula, you need to put 6 degrees. I hope you understand. So this tells you that we can write the cos 12 degrees to be equals to 1 minus 2 the sine squared of what? The sine squared, remember this is like saying cos 2 theta, and our theta is 6. So this will be the sine of 6 degrees. You see now, you just have to solve for sine 6. Then you're good to go. So let's solve for sine 6. First thing first, I know that the cos 12 is P. Okay? We just proved that the cos 12 is P. And then now I still have 1 minus 2 sine squared 6. So let's bring the 1 this side. So this will give me P minus 1. It's minus 2 the sine squared 6 degrees. Then let's divide everything this side by negative. So this is negative, divide that by negative, divide that by negative. This gives us 1 minus P. It's equals to 2 the sine squared 6. Too much work, ne? Because we still have to divide by 2 again. By 2. So this is just like saying 1 minus P over 2 is equals to the sine 6. So I'm just going to put this like this, and then I can square both sides. Therefore, how many marks? I'll definitely check the mark allocation, because I think like this is too much. 6 degrees is equal to the square root cancels, and this will leave me with 1 minus P over 2. And that's it. Wow, that was nice, né? That was very, very nice. So this is how you answer those questions from that question paper, and I'm looking forward. Let me first check the mark allocation before we can end this one. Oh, that was 4 marks. It makes sense, né? And that's how you answer the question using Sketch. Okay, this is where we're going to stop for this one, and I'm looking forward, guys, to see you on question 4. Look at this question for 17 marks. If this is your first time watching my lessons, join the family, subscribe to the channel, and let's work on that question 4 together. And that's it from me. Sharp. Thank you for watching. Okay, so I want us to work on these high order questions. Now look at this question. This is from KwaZulu-Natal past paper. And this is what we'll be eating on this lesson. So we'll be eating angle theta one way. Okay, why is this thing moved? All right, so let's work on this, guys. Let's see what we can do from this question. I'm going to first start with the first question, and I'll definitely take this step by step and make sure that if there's something you don't understand, pause the lesson and try to make sense out of whatever that you are confused with. So if sine 38 degrees is P, determine the value of the following. Guys, before I even go to this 6.1, there are some of the things that I need to do. So I'm going to rewrite that sine 38 equals to P and do my magic. Let me go and do that and see what I can do from that part. Okay. Okay. Let's see. If you check, this is question, what was that question? This is question 6, okay? So on this question 6, I'm going to first rewrite everything that was given on that side, and then I'll take it from there, okay? Okay, so now when I look at this question, we are saying that we are given the sine. Let me just verify this. The sine 38 is equal to P. So this will be the sine 38. This is what I'm given. The sine of 38 degrees. This is equals to P. So remember, any number, any variable, it's over 1. Okay, so I'm going to introduce the shortcut tool. Okay, so if you still remember the shortcut tool, it tells us that when you are working with sine its opposite, which is y, over hypotenuse, which is r. So on this problem, the given problem, we are given y to be p and we are given r to be 1. So what is missing? Let's draw the diagram first so that you can understand what is going on. And you also need to ask yourself, in which quadrant are we going to put our diagram? Right, I'll explain that now so that you can understand which diagram to use. Okay, looking at this will be my 0 degrees. This is 90. And I'll have this as 180. Then this is 270. The last one is 360. So where should I put my diagram? You're going to look at that angle, 38 degrees. So 38 degrees is between 90 and what? And 0, which is quadrant 1. So my diagram should be in quadrant 1. So I'll definitely put my diagram in quadrant 1. So this will be my diagram here in quadrant 1. And this is 90 degrees. This angle here is 38 degrees. So now, when that angle is 38 and this is 90, what will be that other angle? So this is something that you need to ask yourself. If this is, remember, the sum of angles should end up to what? Should end up to 180. So you're going to say 180 minus 38 minus 90 to find that angle. So what I'm trying to say is that that angle will be 180 degrees. You minus 90, you minus 38. Sum of angles in a triangle, and it will give us that angle to be 52 degrees. Right, I hope you understand how I got that one. Okay, so now we are given y, which is the opposite. They say y it's p, and we are given r, which is the hypotenuse, it's 1. What is missing? We are missing x. So I'm going to use the theorem of Pythagoras to find x. Before you answer the question, make sure that you have x, y, and r. So I'm going to use theorem of Pythagoras. So it says that r squared is equal to x squared plus y squared. Okay, so now let me just substitute what I'm given. I know that r is given as 1. This is squared. X squared is what I'm looking for, plus y, which is p. So this will be squared. So I'm going to take the p squared to the other side. This is 1 minus p squared is just equal to x squared. So this is x squared. So now look at this. I have 1 minus p squared, which is equal to x squared. I'm just going to square both sides. Therefore, x, it's plus or minus the root of what? The root of 1 minus p squared. Then you need to decide if your x is positive or negative. And how do you decide that? You look at the quadrant that we have our diagram, which is quadrant 1. All the x values are positive in quadrant 1. All the x values are positive. Therefore, I'm going to conclude and say x is equal to the root of 1 minus p squared. So that's my value of x. Okay, so why is it important that you say plus or minus? Because let's just assume that, let us assume that the diagram was in quadrant 2. So the x was going to be negative root of 1 minus p squared. I hope you guys understand that one. Now that you have everything, you can now start answering the question. So now what you need to ask yourself, how do you know if you have everything, if you are ready to attempt to start attempting question? First thing first, make sure that you have all the sides. This is 1 minus p squared. All the sides of that triangle, you need to know all the sides. Right. Now let's go and answer the first question. The first question says they want us to find the cos 280. Okay, the cos 280. So now, what I'm going to do is that, let me just close that guy because it's going to disturb us. Okay, so you know what I'm going to do to answer this 6.1.1. So they are looking for the cos of the cos of 218 degrees. Okay, so now I need to reduce this angle, because when you work with this, make sure that it's either your angle is 38 or 52. So if it's not 38, if it's not 52, do not use that triangle. So you need to first reduce that. So how can we reduce the cos 218? We're going to check in which quadrant is that angle. Okay, so the cos of 218, it's in quadrant 3 because it's between 180 and 270. So what is going on in quadrant 3? 180, and if I move in that direction, I'm approaching 270. How do I approach 270? By adding theta. So this tells you that I'm going to say this is 180. I'm going to add something. What should I add to find 218? So I'm going to share my calculator now with you guys so that you can understand how this works. Okay, so you're going to say that this will be 218. You subtract that 180, then you'll know what you need to add there. This gives us 38, you see. So this tells you that we need to add 38. So if you add 38 degrees, that will give you 218. Then you do the reduction formula. Where is cos 180 plus 38? It's in quadrant 3. How is cos in quadrant 3? Cos is negative. So this will be negative the cos of that angle, 38 degrees. Then to solve this will be negative the cos 38. We're going to use the diagram to understand what is cos 38 equals to. Now that the angle, we have it in that triangle, which is this 38. So if I'm using that angle, this is my opposite and this is my adjacent, because remember the 90 degrees, it is formed by opposite and adjacent, and this will be my hypotenuse. So if I'm using angle 38, my opposite is P, my adjacent is the root 1 minus P squared, and my hypotenuse is 1. So I'm going to say that according to SOHCAHTOA, cos, it's the cos of theta is going to be adjacent, which is x, over hypotenuse, which is r. Okay, so now this will be negative the cos of 38. So you need to understand what is your x. We just calculated x to be the root of 1 minus P squared. We're going to divide this by r, which is 1. So that's your answer. You can just write this and say this is negative the root of 1 minus P squared. Then now you can move to the next question. Go and collect that next one. So I need you to try and work on 6.1.2 and leave a comment. I need you to be honest and tell me if you've managed to get the same answer that I'm going to get when I do 6.2. I need you to be honest. Pause the lesson, try and work this one on your own. Let's see if we get the same answers. And please comment your answer. I need to see your comments, guys, coming there. So let's see who's going to get this one right. So they say we need to do the cos of 14. So 6.1.2, the cos of 14. Now I'm in an exam, and then now I have so much stress. I'm panicking. My angle is 38 and 52. What does this has to do with 14? You just have to think about it. How can I bring 52 and how can I bring 52 and 38 from that 14? Look at what I'm going to do. I also don't know which angles I'm going to use, what can be done from that. And I need you to look at what I'm about to do. So I'm going to open my calculator, and then I'll start pressing numbers. I'm gonna just press any number, say 90 minus 38. You see, 90 minus 38, that's 52. So I say that, okay, 90 minus 38 gives me 52. Then let me try and something. What is 38 plus that 52? What do we get when we add the 2? What do we get? You see, 90. But what about if I say 52 what about if I say 52 minus 32? What should I get? 52 minus 38, and then this gives me 14. Oh, nice. Now I have the 14 that I'm looking for. And then look at this. I know that I can write this. As you see, I just go on the calculator, punch, try to relate the 38, the 52, and the 14. So I know that we will get 14 if we say the cos of 52 degrees with minus 38. So now I'm happy that these are something that I have on the triangle. But how can we do this? This is a compound angle. This is a compound angle. We are subtracting two angles, and this will be the compound for what? For cos. You go to the formula sheet, you write down the formula for a compound for cos. You're going to write down your formula. You're going to say that if I have the cos of alpha plus, oh, it's we are subtracting, right? So we're going to subtract the cos of beta. What is that equals to? It's equals to the cos alpha, the cos of beta, and then the sign changes from negative to positive. You don't have to stress about this. Just go to the formula sheet, get this formula from the formula sheet, then you'll be good to go. So now from this formula, I can just substitute what I have. I can just substitute what I have. So I'm going to just substitute this and say, I know that I can let my alpha to be 52 degrees, my beta to be 38 degrees. So where there's alpha, we're going to put, where there's alpha, we're going to put 52, and where there's beta, we put 38. This will be the cos of 52 degrees multiplied by the cos of 38 degrees. Then I'm going to add the sine of 52 degrees times the sine of 38 degrees. You see, this is something I can work on because I can use the diagram to find all these things. So look at this, the cos 52. Let's first start with the cos 52. Remember, the cos is what? Now I'm going to change some of the things here. Look at what I'm going to do. Which mark? Okay, I'm just going to use the blue one. So the blue one is when we are using the angle 52. Oh, that's not good. Let me just try to find another strong marker. Which one should we use? Okay, the red one. I think that one can work. So if I'm using 52, which is that angle, the side that is opposite to that one, it's this one. So this one is opposite. Remember, green is when we're using the angle 38, and red it will be when we're using the angle 52. Because you need to check if this is 52, which one is your opposite. The side that is opposite to that angle 52, it's your opposite, and which makes this one to be the adjacent. Right, I hope you guys understand, and I hope you understand how this works. Right? So now what I'm going to do, the first one is the cos 52, and cos is adjacent, which is x over r. So if I'm using 52, what is your opposite? What is your adjacent? So 52 is red, right? So if 52 is red and we are looking for the cos 52, that will be x, which is adjacent. The red adjacent, it's P. So I'm going to say this is P over, and then I have R, which is 1. So this will be P over 1. I'm very sorry, guys, for going up and down there. And then this is multiplied by the cos 38. Remember, 38 is when we are using the angle 38, and my opposite is the green one. Okay, so the green one, 38, this will be the cos of 38, which is adjacent. The adjacent, the green adjacent, it will be root of 1 minus p squared over 1, which is r. I hope you guys are following that. So this will be the root of 1 minus p squared over r. Then close the bracket. Now I'm going to add the sine 52. Right, so if we do the sine 52, 52, rate. Sine its opposite all over hypotenuse. Which one is the rate? The rate is the opposite, right, for that 52. So it will be root 1 minus p squared. So this will be plus the root 1 minus p squared over 1. Then now I'm going to multiply this with the sine 38. Let me not stress about sine 38. Remember, sine 38 was given as p. So it's just p over 1. So I'm going to say this is p over 1. Guys, if you can manage to do this substitution, I'm telling you, from here, everything becomes more easy because you just have to multiply the numerator. So this is like saying this is p root 1 minus p squared. Then we add this with what? With p root 1 minus p squared. Look how beautiful this equation is. These are like terms. So if we add the 2, we just get 2p, the root of 1 minus p squared. That's your answer. You can just leave it like that. Wow. Okay, let's move to the next question. Let me see what we have on the next question. And now let's work with the sine 26, the cos 26. Right, I'm just going to write that down and then I'm going to train you how to work around that angle. I think this one is going to be the easiest one. Let me just put it down here. So on this 6.1.3, we need to work on the sine 26 degrees and then the cos 26 degrees. Guys, remember, you need to think. And when I say you need to think, don't think outside of the exam. Maybe like you are thinking about something else, maybe something happened yesterday, what. Think about what you are looking at, which is the sine 26, the cos 26. So that's how you pass maths. When you are writing maths, just forget about what happened yesterday. Just forget about the problem that you did and you were struggling with. Focus on what you have now. Look at this. The sine 26 cos 26, how can I bring 38 and 52? Either one of them or both of them, how can I bring them to this equation so that I can use that diagram to solve this? What should I do? That's what you need to ask yourself. And then now look at something here. So when we say that the basics are very important, this is what we are referring to. Bonafide, the sine, the cos. What comes in your mind when we work with trigonometry and we have the product of sine and cos? So I know that sine of theta times the cos of theta. This is an identity, but I'm missing something. This should be 2, and this is equal to what? This is equal to the sine of 2 theta. Wow. You see? The sine of 2 theta. So now the difference is that the angle are the same. Yes, that's good. But now I don't have 2. I can't change this into the sine of, you see, I don't have 2. So let me show you how to work around that problem. So I'm going to divide both sides by 2. Divide both sides by 2. Therefore, this tells me that where I see the sine of theta multiplied by the cos of theta, I can substitute that with 1 over 2, the sine of that 2 theta. So what I'm trying to say is that I can definitely change this equation and write it in this form and say this is half the sine 2 of that theta, which is 26 degrees. On your calculator, just say 2 times 26. You'll see the magic. What do we have? 1 over 2, the sine of what? 1 over 2, the sine of 52. You see, this is nice. We know what is the sine 52. Even if you can just refer to your previous questions that you already worked on. Look at this. The sine 52, it was that. So I can just substitute that on this equation. Then I'm done. So this will be 1 over 2 into the root 1 minus p squared, and this was over 1. So that's your answer. The answer is just half root of 1 minus p squared. Easy. Okay, I think I've said much on this question. I think I gave you guys strategies how to work around this question. Focus on what you have, okay? Focus on what you have. Let's move to the next question. Evaluate the following trigonometric expression without using a calculator. Guys, you see, they even write this in bold without using a calculator. And when I will be like, you know what, this is my calculator again. So I'm just gonna punch the calculator. It's fine, you can punch the calculator, but let me teach you what to do so that they don't see that you use the calculator. We'll definitely work on that, okay? Just give me a second. We're going to solve this problem and we're not going to have any problems, okay? So let's work on that. I'm just going to take the given problem, I'm gonna rewrite it on the other side, then we'll start working on it. Okay, so I'm given 6.2. Okay, so on this 6.2, the problem goes like this. They say this is 2 the sine of 2. This is 2 the sine 165 degrees. And then we multiply the cos 195 degrees. So everything here is divided by, okay, everything is divided by the cos 45 multiplied by the sine 15 minus the cos 15 times the sine 45. So now when I see a pattern on bottom left. If you still remember, look at this. Cos alpha, cos beta, sine alpha, sine beta. You see? So the cos alpha, the sine beta. So the angle that is on cos, it should be the same on the angle that is on sine. The angle that is on cos is the same as the angle that is on sine. Look at this. This is what I have. The cos 45, the sine 45. So this is a what? This is a double angle for what? This is a double angle for sine. I hope you understand that. And if it's a double angle for sine, oh, this is cos 45, sine 15. So is different to this one. Eh? This one was for cos, and then I'll definitely write it down with the one for that sine. So let me quickly remind you what it looked like. So this will be, since this one is negative, we know that it will be for sine, but you just have to go on your formula sheet, verify everything. You'll see that this is the compound for sine. So this will be the sine of A, then minus B. It's equals to the sine of A. Okay, it's equals to the sine of A, the cos B. Then the sine remains the same, and this will give us the cos of A, the sine of B. Right. So this is a multiplication. So this is a multiplication. I'm going to just leave that the way it is because it is in the form that we need it. So everything is good on that side. So the only thing that I can arrange maybe is this one, the cos 45 and the sine 45, and write it in that form as sine A cos B, cos A sine B. It's fine, but since it's the product, the order doesn't matter. When I say the product, 2 times 5 is the same as 5 times 2. Both of these gives us an answer of 10. So this tells you that the bottom part, everything on the denominator, I can write everything on the denominator as the sine of A, which is 45, then you subtract B, which is 15. So I'm going to substitute everything on the denominator as that. But now I have some of the things that I need to fix on top, which is doing the reduction formula. I have a very big angle, 165. I also have 195. So I need to reduce those two angles. Okay, let's talk about how we can reduce the angles. Let's start with 65. Let's start with the sine. 165 degrees. In which quadrant is 165? That's what you need to ask yourself. If I have a Cartesian plane like this, I know that this is 90, this is 0, this is 360, then this is 180. Look at this. 165 is between 90 and 180. So it's in quadrant 2. So if it's in quadrant 2, how do I move from 180 to 90? I subtract. So I can write this as the sine of 180. What can I subtract from 180 to get 165? I need to subtract 15 degrees. Okay, so now what you're going to do, you ask yourself, how is sine 180 minus 15 in quadrant 2? Sine is positive. This changes into the sine of 15 degrees. So this tells you that when we do the reduction formula, where there's this sine 165, I'm going to substitute that as sine 15. By writing sine 15, you have a mark. They'll definitely give you that mark. Then now I need to also reduce the cos 195. So I'm going to say the cos of 195 degrees is equal to, in which you ask yourself, this is how you do the reduction. Ask yourself, where it's 195? It's between 180 and 270. Okay, so since it's between 180 and 270, you're going to ask yourself, how do I move from 180 to 270? I'm going to add. So this will be the cos of 180. I need to add something to get 195. So we need to add 15 degrees. So then you're going to ask yourself, how is cos in quadrant 3? Cos is negative. Let's change into negative the cos of 15 degrees. So what I'm going to do is that where I see this cos 195, I'm going to sub in that by negative the cos of 15 degrees. Wow. Let me just rewrite everything down and let's see what we have so far. So this will be 2 the sine of 15 degrees multiplied by into the bracket negative the cos of 15 degrees. So everything here is divided by, if you still remember, we said on bottom, we're going to write that as the sine into I think we talked about, let me just look at the compound angle. I just want to confirm something, okay? Okay, so I think I did confirm that compound. Let us continue with this one. Okay, so now we said on bottom, we're going to write this as the sine of 45 degrees with minus 15 degrees, right? Then what do we have on top? So let me arrange the top part. This will be negative 2 the sine 15 degrees, the cos 15 degrees. Then everything is divided by the sine 30. The sine 30 degrees. Okay, and look at what I have here, okay? When I look at what I have here, remember we talked about that the sine of 2 theta is equal to 2 the sine theta times the cos theta. And this is what we have, the sine theta multiplied by the cos theta. But this time, this one is that 2. So we can change this part here. We can change this part and write it as 2 times, okay, sine, or let me write it down. So we can change this part and write it as negative 2. The sine of 2, our angle is 15 degrees. Everything is divided by the sine 30. Okay, so this is equals to negative 2, the sine of 2 times 15, that's 30. And then I'm going to divide everything by the sine 30. So the sine 30 cancels, and this leaves me with an answer of negative 2. So when I solve this, I get an answer of negative 2. Right, and that's it for this question. So these two cancels, then this leaves me with an answer of -2. Okay, let me go to the next question, number 6.3. Okay, so 6.3, we are given k to be equals to the √3, the cos x plus sine x, and write k in the form of t into sine of x plus theta. Guys, look at this, né? Look at this part. Look at this part. I'm going to remember I said focus on what you have. I have the sine of two angles that where we are adding two angles, okay? And if we are adding two angles, this is a compound angle for what? For sine. So if I have the sine of alpha plus beta, this will be equal to the sine of that alpha, the cos beta, and then the sine remains the same. This will be the cos of alpha, the sine beta, right? So I can change this guy here, write it in that form, okay? So I need to say whatever that I do, I need to, this thing, it is in that form. So basically what they did on that, they reduced this and write it in that form. Then they have a certain value there, which is t. So how can I put this k in this form? Okay, how can I put this k in this form? Then from that form, okay, let me just, I don't know how to explain this, but let me try my best to explain this. So we're going to start with, we need to change this guy. We need to change this guy and write it in that form where we're going to have sine times cos. We only have cos, we only have sine. So we need to change it and write it in that form where we're going to have sine and cos, cos and sine. So how can we do that? First thing first, look at this. This needs you to be familiar with the special angles, okay? This needs you to be familiar with the special angles. So I know that on the special angles, when I have the √3, I can divide that √3 by 2. And what is that equals to on the calculator? That is equals to the sine of 60 degrees. I'm not sure if you guys understand what is going on. So I know that √2 over 2 is equal to sine 60. So from this question, how can I bring the 2? I can just say, if I multiply this, it's like saying I can take out that invisible 2 out as a common factor. I'm not sure if you are following, but let me try and write this down on the other side, okay? And we'll take it from there. So what's going on here is that we said that the sine of alpha plus beta, it's equals to the sine alpha, the cos beta, the sine remains the same, the cos beta, the sine of alpha. And what are you given? I'm given k to be equals to the √3, the cos of x plus the sine x. Okay, so now when I look at that √3, what comes in my mind is that where we have √3, this has to do with the special angles, the special triangle. So I know that I can create √3 over 2 from that special triangle. But now, how do I bring the 2 here on this guy? How do I bring? I can write this k in this form. Say 2 out as a common factor, and then inside the bracket, I need to put the number that when I multiply it with 2, it will give me √3 the cos x, which is just √3 over that 2. Right. The reason I need this is that I need to sub in that as the sine of 60, which will be the sine of alpha. I already have the cos beta, which is the cos x. So I'm going to multiply this by the cos x. So I think this is high order question. If you don't understand this one, you don't have to stress, because this type of questions, they change every year. If you don't understand this one, just relax, don't worry about it. Let's just do this for fun. Okay, so now the sine x here, I need a number that when I multiply it with 2, it gives me sine x. So that number, it will be 1 over 2, because 1 over 2 times 2 is just 1, which we multiply this by sine x. So this tells you that if we multiply out the bracket by that 2, it takes us back there. I hope you guys understand. And we know that 1 over 2, that will be what? 1 over 2 is the cos of 60. So let me just try and re-explain this question, because guys, I have all the time left. I can just explain this even 10 times until you get it right. So look at this. We created the cos of alpha, which is the sine alpha, which is the sine 60. Then when I look at this, I already have the sine. I need to create the cos. So I know that to get the cos, I'll get it if I say the cos of 60. And I know that the cos of 60 is just half. I hope you guys understand that part. Remember, if you don't understand what is going on the question, don't stress, just relax. This type of questions, they change every year. This is high order questions. Right? That's why I chose to work on this paper, because I saw a lot of interesting questions here. So now what's next? What should we do now? What I'm going to do now, k, this will be k is equals to 2. Root 3 over 2, I know that I can substitute that as what? The sine of 60, and then times, this is the cos of x, then plus 1 over 2, I can write that as the cos of 60 times the sine x. The aim is to have this. So if we have this, we can write this as k is equal to, they want us to write it in the form of t into sine of x plus theta. So this will be 2, which is t, into the sine, then we add the angles. What are the angles? 60 and x. So we're going to say 60 plus x. Then you're done. You just have to leave it like that. You are done. This is in the form of 2 into the sine of x plus theta. Nice. Okay, and then you can just leave it like that. Next question, write down, okay, hence calculate the value of t and q. When they say calculate, they are definitely confusing you. Instead of calculate, they want you to determine. So we know that this is t. Where there's t, that's 2. Therefore, to answer that 6.3.1, we're going to say t is 2. And then x, that's 60. Therefore, the value of x, that's 60 degrees. Simple. That's how easy the question is. Next question. Write down the maximum value of k. Okay, the maximum value of k, guys, look at this. When they want you to write down the maximum value of k, when we look at this carefully, you know what I'm going to do. I have 2, the sine of x plus 60, right? And this is like what is this? Trigonometric function for sine. So the trigonometric function, the standard form, it's in the form of a, the sine of theta. What is a? So basically the x plus 60, that's your theta. Your a is 2, which is the amplitude. What is the amplitude? It tells you the maximum value, because the graph of sine looks like this. So when it looks like this, it's going to start at 0, then it moves up like this. So the value of A is the amplitude. So this point here is 2, which is the maximum value. That's why this question is 1 mark. So the maximum value is 2, which is the value of A, the amplitude. So to answer this, 6.3.3, we're going to say the maximum value is 2. Simple. Wow. I think we've been working on this for the past 40 minutes now. This question paper. This is a very nice one. Next question, 6.4. It has to do with identities. So I'm going to rewrite the identity. Just for fun, we're going to work on 2 methods to solve this one. We're going to work on it 2 methods. Then it's up to you which method you prefer. Also, please make sure that you leave the comment, because now when I say make sure that you leave the comment, I need to see who watched the lesson up until we do 6.4. So let's find all those learners who watched the lesson until 6.4. Right. So now when I'm done solving this, guys, I need you to comment, tell me which method you prefer. Which method it's easy for you. Just put on the comment section, say method 1 or method 2. So let's see how many of you stayed until 6.4, because I know that most of the time when you say that, hey, this question is too much for me, you just pass and go to the next video. But let me just work on this. So I'm going to rewrite the question and I'll definitely start working on that. So I'm given that the identity on that 6.4, it's given as the tan, 2 tan theta, then we subtract to the sine of theta. Everything is divided by 2 the sine squared theta. Okay, so let's start with method 1, and I'm looking forward, guys, to your comments. So method 1, this is what I'm going to do on the first method. Let's first change, this is not sine theta, this is sine 2 theta, né? This is sine 2 theta. So first thing first, where there's tan, I know that I can write this as sine theta over the cos theta. That's what I need to change first. And this is an identity. Remember, so what I did on this one, where I see the tan of theta, I substitute sine theta over the cos theta. Where I see the sine 2 theta, that's 2 sine theta, the cos theta. So let's quickly substitute that other part. So this will be minus 2 sine theta, the cos theta. Then everything is divided by 2, the sine squared theta. Right. So the first method that I want to show you guys is that when I have something like this, I can say that focus on what you need on top. Okay, focus on what you need on top, which is on top I need to have only sine. Okay, so I'm going to solve this by inspection. When I say by inspection, it's like saying you are trying to cook something. You understand? So look at this. I'm trying to cook something there, and when I'm trying to cook something, this is what I'm going to do. I know that I have something in common, which is sine and sine. So if I take out the sine out as a common factor there, one sine will cancel that one sine on the denominator, and then on top I'll be left with no sine. But if I'm left with no sine, how can I bring back the, you see guys, how can I bring back the sine? That's what you need to ask yourself. I can bring back the sine if I have 1 minus the cos squared x. Oh guys, sorry, I'm not just trying to be like maybe playing with your mind or trying to act smart or something. This is how I need you guys to think. I'm saying that on top I have sine, okay? So I know that if I can get to a point that I have 2, if I get to a point that I take that 2 sine theta out as a common factor, okay? If I take out the 2 sine theta as a common factor, that sine theta on top, it will cancel 1 of sine theta on bottom, and the 2, it will also be cancelled, because we are trying to prove that this is equal to the tan of theta. Right, so we are working on left hand side now. I hope you guys are still with me. So now I'm saying that if I get rid of sine on top, how can I bring back the sine? The only way to bring back the sine is if we have 1 minus the cos squared of theta. This is equals to the sine squared theta. Then that's when we're going to also cancel that remaining sine on the bottom. Nope. Okay, it's fine. Let me just do what I'm saying. So now I see that I have this cos on the denominator. I need to get rid of that cos. And I need to have cos squared. So I know that if I can multiply both by cos and bottom by cos, I did not change anything because I need to get rid of that cos. So I'm going to first take the cos, which is the one on top. Then I need to multiply the 2 of sine theta over the cos theta. Then minus, we take that cos again. We're going to multiply the 2 sine theta, the cos theta. Right. Please, if you don't understand what's going on, just wait for the next method. Maybe the next method is for you, né? And then I'm going to divide everything. This times that is 2 the sine squared theta times the cos theta. Right. So now look at this. This is what I was trying to explain, is that I'm solving by inspection. So I know that these 2 cancels, and this times that will give us the cos squared theta. Right. Let's rewrite what we have now. So I'm going to say I'm left with 2 sine theta on top, 2 the sine of theta. We minus what? We're going to minus 2 the sine theta, the cos squared theta. Okay. Then on the bottom we have what? On the bottom we still have 2 sine squared theta times the cos theta. So you check what you have on top. On top, I said we are creating 1 minus the cos squared, right? Then we can be able to change that into the sine squared theta. So I need to take out that 2 sine theta out as a common factor. Then I'm left with 1 minus the cos squared theta, which is what I need on top. So this will be divided by 2 sine theta times sine theta times the cos theta. I think you understand why I did what I just did now. I just have to separate the sine squared theta and write it as sine theta times sine theta, so that these 2 can cancel. Then when I change the top part, I'll be left with 1 minus the cos squared theta over sine theta times the cos theta. But now I know that 1 minus cos theta is the same as what? Is the same as sine squared theta over sine theta times the cos theta. So I think now you know that the sine squared theta, we can definitely change that and write this as the sine theta times the sine theta. So that 1 sine theta, they will cancel with that sine theta. So on top, you're only left with what? With the sine of theta. So let me rewrite this. The sine theta times sine theta over the sine theta times the cos theta. So these two cancels, and this is equal to sine theta over the cos theta, which is just tan theta. Therefore, left hand side is equal to right hand side. Left hand side equals to right hand side. This is true. So I'm saying that if this is not your method, and maybe the method that I do next, you will definitely understand that method. Okay. All right. That was method 1. So if you understand method 1, please now wait for method 2. Let's see what we can do on the second method. So remember, we have 2, the tan theta and minus sine 2 theta over 2 sine squared theta. Okay, so now what we are saying is that the top part, this part here is just sine theta over the cos theta, and we're going to substitute that as 2 sine theta cos theta. Let's go and rewrite the equation. So this will be 2, what is this? This will be 2 sine theta over the cos theta minus 2 sine theta the cos theta, and everything is divided by 2 sine theta sine squared theta. So now look at what I have now. I'm going to indicate now. Look at this, move with me. I have 2 sine theta. I have 2 sine theta. Can I take that out as a common factor? Yes, I can definitely do that. So I'm going to write the 2 sine theta out as a common factor. Then I'll be left with 1 over the cos theta minus the cos theta. And everything is divided by what? Everything is divided by 2 sine theta times sine theta. So this is what happens. I separate the sine squared theta so that I can cancel this part. Then what do I have on top? I have 1 over the cos theta minus this cos theta. I'm going to write it as over 1. Then everything here is divided by the sine theta. So there comes the most interesting part, which has to do with LCD on top. Your lowest common denominator on top is the product of your denominator, which is just cos theta times 1. That's cos theta. Then you're going to take every term on top. You multiply every term by that LCD. The answer that you get, you divide by that LCD. Okay, let me write this down so that if you don't understand what I'm saying, maybe this can make sense. So now what I'm saying is that you take the cos theta, which is your LCD, you multiply the first term, which is 1 over the cos theta, close the bracket, minus the cos theta, you multiply that term, the cos theta, close the bracket. The answer that you get, you divide that by your LCD, which is the cos of theta. Remember, everything is divided by what? The sine theta. Nice. Then now the 2 cancels, and then we're left with 1 minus the cos squared theta on top. So this will be what? This will be 1. This will be 1 minus the cos squared theta, and everything is divided by what? The cos theta. Then I'm going to change this now. I know that the sine theta here is over 1. So I'm going to change the division into multiplication, but I multiply by the reciprocal, which is 1 over the sine theta. So I just have to multiply by the reciprocal. What is that equal to? This will be 1 minus the cos squared theta is just sine squared theta over the cos theta times sine theta. Then now this will be the sine theta times the sine theta, everything divided by the cos theta times the sine theta. These 2 cancel, we just left with sine theta over the cos theta. Therefore, this is just tan of theta. Now you can conclude left hand side is equals to right hand side. Therefore, left hand side is equal to right hand side. Please, I don't want to see a comment where someone is saying that I don't prefer both methods. I don't understand any of those methods. No, that's highly impossible, because I think the second method it's nice, until it comes to this part where you have to multiply every term by that cos theta and divide everything by the cos theta. But if you understand, I hope most of you will say the second method, because the second method is the easiest. We just have to follow the step. But the first one, there's too much confusion because of the inspection. If you, it's like saying we are working on this without an A. Oh, okay. The last question, guys. Please, let's work on the last one of this question paper. High order questions. Okay, hence determine the value of theta. This is too much. Now, the value of theta for the above identity to be undefined. So if I have A over B, for this fraction to be undefined, B must be equal to 0, because if I divide by 0, I get undefined. So to answer this, you're going to take whatever that you have there. You're going to say to the sine squared theta is equal to 0. Then this will be undefined. Then you solve for theta. Therefore, divide both sides by 2. You get sine squared theta 0. Then what will be theta? So theta, if I say sine theta, I can write this as the sine theta everything squared. It's equal to 0. Square both sides. Square both sides. Therefore, the sine of theta is 0. And the question is asking, hence determine the values of theta where theta is an element of 180 and 360. That will make the above identity defined. When you get here, guys, you don't have to do the sine inverse, what. You just have to know how the sine graph looks like. So the sine graph looks like this. It starts at 0, it approaches 90, then 180, 360. So look at this. This is 0. This is, okay, this is 0, this is 90, and then this is 180, this is 270, this is 360. So you can see that from the graph there, at this point, 0, 0, at this point the sign is also 0, and at this point the sign is 0. So now they are asking, where is the sign 0? It's like saying, where is the y value 0? At the x values, it's at 0 when x is 180 and 360. So that's your answer, 180 and 360. So if the theta is 180 and 360, then we're going to definitely get undefined for that solution. And that's it for this question, guys. Remember, high order question. So this is where I'm going to stop for this one. And guys, please remember, leave those comments. Let me see if you guys really understand those methods that we discussed about. Okay, great, Charles. Then let's look at this 8.2. Let's see what we have here on this 8.2 now. So looking at this question, I'm just gonna try and read the statement. So I'll make sure that you guys understand everything here now. So the statement says that in the diagram SBT, SA and TC are tangents. So we have a lot of tangents, and then it's fine. We'll definitely go back to some of the statement when we are working on questions. And they say that a tangent to circle B, A and C respectively. So AB is produced to P and AC is produced to Q, such that Q lies on the line PQ. And now they say that, I think this one it's also important that we go into too much details on that. In triangle APQ, so I'm going to indicate which triangle are they referring to. So this is APQ. In that triangle, they say that the proportionality AB over AP, it's equals to AC over what? AQ. So I think you guys understand how the proportionality works. If we can do the proportionality inside a triangle, this tells you that the third line, which is this line, the midpoint line, it's going to be parallel to what? It's going to be parallel to the third line of the of the triangle. Okay, so that's what they are trying to tell you. They are trying to tell you that AB and they are trying to tell you that AB and not AB, BC and PQ are parallel. So I'm just going to put it down here and say this tells us that the line BC is parallel to what? To PQ, and we'll see how will that help us when we answer questions. Okay, first question, use the above information to prove that AT is equals to T1 or A2. So this is A2. We need to prove that A2 is equal to T1. So a quick tip that I can give you is that when they want you to prove that two angles are equal, you know what you need to do. You start with A2, or you can start with T1. Find all the angles that are equal to A2, then also find all the angles that are equal to T1. If you find that there's that one angle that is equal to both of them, then you can conclude and say that these two angles are equal. Let's work on that. I'm going to look at A2 and I'm going to try and find all the angles that are equal to that A2. Okay, so I'm just going to look at that A2 carefully and find all the angles that are equal to A2. So if this is a point of a tangent, we can see that this will be my tangent, right? So if this is my tangent, I'm not sure if this, let me not do with that part because this will give me C3. Okay, so I need to check, you know what I'm going to do? This is my A2, then I'm going to check the chord that subtends that A2 at the circumference, which is this chord. So, and when I look at this chord, I can see that this chord we have an angle that is between a tangent and that chord. So this angle here, it should be equal to A2. So angle B3 is equal to A2. Okay, to answer 8.2.1. So on 8.2.1, we're going to say that B3 tan chord theorem, right? Is that correct? Yes. B3, angle B3 is equal to angle A2. Let's keep on finding the angles that are equal to A2. Let's keep on finding those angles that are equal to A2. So now, when I look at this, angle A2, when I look at angle A2, which other angles again are equal to A2? So look at this other tangent here. Then this line is that chord. So this tells you that this angle is equal to A2, tan chord theorem. So this one was tan chord theorem. And then we also saying that A2, angle A2 is equal to angle C2, reason tan chord again. Right. So now when I go to angle T1, this is my angle T1. Right. So I can see that this angle T1, since this line here, it's parallel to that line. We can look at alternating angle. Look at this. T1, angle T1, it's equals to angle C2. Look at this. Both A2 and T1 are equals to C2. Remember I said when they want you to prove something, when they want you to prove that two angles are equal, you find all the angles that are equals to those angles. And if you find that there is a certain angle that is equal to both, then you can conclude. So the reason for this one, T1 is equal to C2, this will be alternate angles because BC is parallel to PQ. This was given here. So I'm going to conclude and say, since A2 is equal to C2 and T1 is equal to C2, therefore, we can conclude and say that angle A2 and angle T1 are equal. Right. And that's it for this one. We can move to the next question. Next question, 8.2.2. prove that triangle ABC is similar to triangle TCQ. Okay, let me just try and clean my board. So you know what I'm going to do? I need to highlight the triangles that they are working on, they are referring to. Right. I'm going to highlight those triangles that they are referring to. Let me see. ABC, ABC. So this is my A, B, C. So this is the triangle they are referring to. They want us to prove that this triangle is similar to what? TCQ. It's similar to TCQ. Guys, when you prove that two triangles are similar, you just have to find angles that are equal in these two triangles, okay? Or sides that are equal in these two triangles. So you're going to focus only on these two triangles and tell us which angles are equal. Simple. So you just focus on these two triangles, find angles that are equal. Okay, so in this triangle, so when you answer 8.2.2, you need to tell the marker that I'm working in triangle ABC and triangle TCQ. Okay, so let's first look at this. Let me look at, I can start with any random triangle. Maybe let's say I start with A2. Remember, we just proved that A2 and T1 are equal. So A2 and T1 are equal. Then I'm going to write this down, that T1 is equals to angle A2. Then your reason is that proven. Why? We did this in the previous question. Then I'm going to look at B2 and try and see in that other triangle which angle is equals to B2. So when I look at B2, I don't think it's easy for us to look at that angle. But look at this. I need you to pay attention on this. Remember, this line is parallel to that line. So since they are parallel, I'm looking at a pattern here. Corresponding angles. Can you see? Corresponding angles. They form an F. Right, they form an F. So this angle C3 is equal to that angle Q. So angle C3 and angle Q are equal. What will be the reason? Corresponding angles, because BC is parallel to PQ, 100%. So now, since we have two angles that are equal, we can conclude and say, therefore, the remaining angles are equal, because sum of angles in a triangle, they should end up to 180 when you add them. So if I have an angle like this is 60 and this is 40, and I have another angle that has 60 and 40. So when we add this angle, they should 180. So this tells you that even these two angles are equal. So what I'm trying to say is that we can conclude and say angle B2 is equals to that angle C1. So then when you have three angles that are equal, the reason for this one, you can say these are the remaining angle. Okay, or if you don't want to say remaining angles, you can say the interior angles of a triangle. Then we can conclude and say these two triangles, ABC, is similar to triangle P. Oh, this will be to TCQ. TCQ. So these two triangles are similar. What will be your reason? Angle, angle, angle. Okay, that's your reason. Then you are done with the proof. Moving to the next one. 8.2.3. ABT is a cyclic quadrilateral. We need to prove that ABT is a cyclic quadrilateral. So I'm going to remove everything there, and then I'm going to try and do those points and see what kind of a shape I have there, and then we'll take it from there. So ABT from A to B. Okay, AB, and then from B to T. ABT what? ABTQ. So we need to prove that this is a cyclic quad. So how do you prove that something is a cyclic quad? What should you look at? You need to understand the properties of a cyclic quad. Number one, opposite angles of a cyclic quad are supplementary, meaning that when you add opposite angles, you get 180. Number two, exterior angle of a cyclic quad is equal to the interior angle. The opposite interior angle. I'm going to explain that. So if I have a cyclic quad like this, and this is my cyclic quad, and let's say I put an exterior angle, this part, it's equal to that interior angle. So if we can manage to prove that an exterior angle is equal to that, then this is a cyclic quad. So another way to prove a cyclic quad is that if you have a circle like this, and then you have two angles that are subtended by the same arc. So two angles that are subtended by the same arc, like this. Two angles subtended by the same arc, and maybe this is A, B, C, D. So angles in the same segment. If these two angles are equal, then we can conclude and say A, B, C, D is a cyclic quad. Another way to prove a cyclic quad is that opposite angles of a cyclic quad are supplementary. So if you add this angle with that angle, you get 180. So those are the things that you need to prove. Okay. Let me look at this, and then we're going to discuss how we can attack the question. So your focus should be on the diagram that it is in purple. So please make sure that let's first test this one and see if we can use this one. So this is what I'm going to first start with, because this one won't work. Why? Because you can see that other points that are outside of the circle. So this one won't work. And then let's just first test the exterior angle. So let me, if you pay attention, we have this angle here. Let me indicate my exterior angles first. So this angle here, that's an exterior angle of that cyclic quad. Another exterior angle, I think, is this one here. That's another exterior. So what I need you to do, I need you to focus on proving that B1 is equals to angle B1 is equal to angle Q. If you can prove that, then you're good to go. That's a cyclic quad. Another thing that you can prove is that angle C3, if you can manage to prove that T3 is equal to angle A2, then we can conclude and say this is a cyclic quad. So I'm going to start with B1 and see how can I prove that B1 is equal to Q. You see, that's how you attack the question. It's not like we always know the answer. We just have ways to find answers. That's how you do maths. Okay. So on this one, 8.2.3, on this 8.2.3, I'm going to say that when I look at this, I need to find all angles that are equal to B1. And if you look at the diagram, this is a tangent. So B1, the angle between a tangent and a chord, is equal to the angle subtended by that chord at a circumference, which is C3. So B1, angle B1 is equal to angle C3. Right, but remember, from the previous question, we proved that angle Q and C3 are equal. If you still remember, where is that? I think we did, C3 corresponding angle. So we proved that angle C3 is equal to angle Q. Right. The reason for this one, the first one is tan chord. And the reason for the second one, you can say corresponding angles, or you can say this was proven. Proven, or you can say C3 is equal to Q because of corresponding angles. Right. So look at this. Both B1 and both B1 and Q are equal to C3. Therefore, you can conclude and say that angle B1 is equal to angle Q. So you can see that since they are equal, this is going to be what? This is going to be a cyclic quad, because this is an exterior angle. This angle is equal to that angle. So it's an exterior angle of a cyclic quad. So therefore, I can say ABQ is a cyclic quad. So you can also give them a reason why you arrived at that conclusion. You can tell them that the reason is that I have the converse theorem, which is the exterior. The reason will be the exterior angle. It's equal to the interior angle of that cyclic quad. Right, that's how easy the question is. I know I keep on saying that questions are easy, right? So another way is that, guys, I just want to give you like an advice before we do the last question. Before we go and eat that 5 marks, let me give you something very important, guys. I know that we always rely on watching YouTube videos for maths lessons and also like maybe watching live TikToks when someone is teaching math. Let me tell you guys how this works. You don't have to always rely on someone to explain something for you. When you get into YouTube, you want to see a video, you need to work on how is this person approaching questions. What are you learning from this question? Do I have a certain style that I use to approach questions? How do I analyze questions? You understand? Because all these things, they make sense. Why? Because I'm explaining this to you. But let's say I just give you the question without giving you explanation. Will you be able to do all these things? So when you come here, please make sure that you know the basics so that you are building from what you know. And also try to solve problems on your own, and you'll see that you will improve. Then when you come to the YouTube or TikTok or wherever where you watch lessons, you come with the knowledge. You just want to build from the strategies that you use to analyze your question. You understand? So yeah, and let's just work on the last question. So what I'm trying to say, guys, is just basics are very important to understand the basics, because if you don't know the properties of a cyclic quadrilateral, you won't be able to answer 8.2.3. So let's say that I explain this part only. Then in the next exam, maybe they bring it like this and they want you to prove that ABC is a cyclic quad, or they just bring it like that. But when I only learned this method where we prove the exterior angle, you see, so you need to know all the properties, and you see that if this is not working, I can try and prove this one. If this one is not working, I can try and prove that one. I hope that you guys get my point. Okay, right. Okay, so I want to make space for the last question. The last question says that prove TQ is a tangent to a circle at TBC at T. So when they say something like that, I'm going to first, let me just clean my board, and then I'm going to write a line, or maybe we can create a circle on that points that they are referring to. Then we'll take it from there. They want us to prove that TQ is a tangent to a circle TBC. So let me first draw my circle TBC. TBC, this is CB and T. So let's say maybe I try and put my ugly circle there on the diagram, and that's my circle. So they want us to prove that. Okay, I hope you guys understand how my circles goes. Okay, I think now I'm going to mess up these angles here. Okay, I think you understand what I'm trying to do here. Okay, that's my circle, right? So the question is saying that we need to prove that TQ, that this TQ is a tangent. So if TQ is a tangent, what should you prove? It's easy. You just have to prove that this angle, it's either you prove, let me show you guys. You see, that's exactly what I'm talking about. Knowing how to approach the question. When they say it's a circle at what? You draw the circle. Then you have your tangent. So when they say what is that? They said at TQ. So we can prove that this angle T1 is equals to B3, né? Or alternatively, we can prove that, remember, this is a straight line. So this is the whole tangent. We can prove that T3, what is this? We can prove that T3 is equal to what? C2. I hope this makes sense. I hope you guys understand what I'm trying to do here. Right. I hope you guys understand that. So if we can try and prove that angles, then we are good to go. So let's work on something here. I think we are missing something from the statement. Okay, I guess I was wrong. All right. Let me, I'm still trying to think how I can solve this question. How can I solve the question? Because when I look at this question, look at this, I can see that the line TB, this line, it's equals to that line. And someone will be asking, how, say, why is that the case? If I have a circle like this, and I have a point like this and a point like this, and then we have a tangent drawn from the same point, the line drawn from the same point are equal. So these two lines will be equal, okay? Okay, because they are all drawn from point T. So since they are equal, this tells me that this angle here, the B3, is equal to angle C2. Let me go and write that information down. I'm not sure if this is part of my answer, but I'm going to put it down and then I'll see what I need to do next. You understand? You just have to write everything down. Tell the marker that, okay, so far, TB is equals to CT. So TB is equal to TC, and the reason tangent from a common point. We're going to say the reason is tangent from common point. Okay, good. Therefore, we conclude and say, therefore, this gives us an isosceles triangle. Base angles of a triangle B3 is equals to angle C2. Reason, you're going to say angles opposite equal side. Angles opposite equal sides. Right. So now, from that information, I'm just trying to find, you know what you need to do. Look at what was the aim. What was the purpose? Is to prove that this angle is equal to that angle, or this angle is equal to that angle. So I'm going to look at what is angle T1 equals to, okay? Or what is angle T3 equals to. Okay, so now I can say angle T3 is equals to what? Angle T3 is equal to angle C2. Reason is that this line is parallel to that line. So they form an alternate. And also, angle T1 is equals to what? Angle T1 is equal to angle B3. Same reason. Alternate angle. So this is alternate angles. This is also alternate angles. So now I can definitely conclude. Look at this. I have B3. Okay. Okay. I'm trying to say B3 and B3. You see, both of B3 are C2 and T1. Both of them are equals to what? What is this? Both of them are equal to B3. So can we conclude and say C2 and T1 are equal? So also we can say that B3 is equals to T1. We can conclude and say B3, angle B3 is equals to angle T1. Because when I look at this, I'm not sure if this makes sense, because if I can't understand what I'm saying, what about you on your side? What about you on your side? So let me just try work around these things, okay? We are saying that B3 is equal to C2, angle opposite equal side. So I think that if I can remove this part, maybe let's not focus on that part. Then now we are saying that T1 is equals to, you see, this is where I made the mistake. T1 is equals to angle C2. Okay, let me quickly fix it that T1 is equal to angle C2. If I don't understand what I'm saying on my side, what about you? Are you good? Okay, I hope this will clear the confusion, eh? Because if I'm confused myself, I just feel sorry for you. So someone might also lose interest and close the video. Okay, but remember, this is how it is. Learner, when you do math, you just don't get everything right. I get right. And also, when you do math, don't always rely on the memo. Just try to solve your problems on your own. So now we are saying that T1, angle T1 is equal to angle C2. That's alternate angles. So now look at this. Both B3 and T1 are equal to C2. Then I can conclude and say angle T1 and B3 are equal, which is what I was trying to prove, is that this angle is equal to that angle. So this is Stanford theorem. So since they are equal, I can say that TQ is a tangent. TQ is a tangent. And what will be the reason for that? Stanford theorem. Stanford theorem. Tell the marker, Stanford. I hope you guys had a great one on this one. I hope you really understand how to solve these questions. Please make sure that if there's something you don't understand, pause the lesson, try to make sense of whatever that you are missing and work this thing out. Okay, right. And that's it from this lesson. Okay, let's work on the next question and see what we can do from the next one. I'll see you guys on the next one. Thank you very much. Okay, great, Charles. Then let's look at this 8.2. Let's see what we have here on this 8.2 now. So looking at this question, I'm just gonna try and read the statement. So I'll make sure that you guys understand everything here now. So the statement says that in the diagram SBT, SA and TC are tangents. So we have a lot of tangents, and then it's fine. We'll definitely go back to some of the statement when we are working on questions. And they say that a tangent to circle B, A and C respectively. So AB is produced to P and AC is produced to Q, such that Q lies on the line PQ. And now they say that, I think this one is also important that we go into too much details on that, in triangle APQ. So I'm going to indicate which triangle are they referring to. So this is APQ. In that triangle, they say that the proportionality AB over AP, it's equals to AC over what? AQ. So I think you guys understand how the proportionality works. If we can do the proportionality inside a triangle, this tells you that the third line, which is this line, the midpoint line, it's going to be parallel to what? It's going to be parallel to the third line of the set of the triangle. Okay, so that's what they are trying to tell you. They are trying to tell you that AB and they are trying to tell you that AB and not AB, BC and PQ are parallel. So I'm just going to put it down here and say this tells us that the line BC is parallel to what? To PQ, and we'll see how will that help us when we answer questions. Okay, first question, use the above information to prove that AT is equals to T1 or A2. So this is A2. We need to prove that A2 is equal to T1. So a quick tip that I can give you is that when they want you to prove that two angles are equal, you know what you need to do. You start with A2, or you can start with T1. Find all the angles that are equal to A2, then also find all the angles that are equal to T1. If you find that there's that one angle that is equal to both of them, then you can conclude and say that these two angles are equal. Let's work on that. I'm going to look at A2 and I'm going to try and find all the angles that are equal to that A2. Okay, so I'm just going to look at that A2 carefully and find all the angles that are equal to A2. So if this is a point of a tangent, we can see that this will be my tangent, right? So if this is my tangent, I'm not sure if this, let me not do with that part because this will give me C3. Okay, so I need to check, you know what I'm going to do? This is my A2, then I'm going to check the chord that subtends that A2 at the circumference, which is this chord. So, and when I look at this chord, I can see that this chord we have an angle that is between a tangent and that chord. So this angle here, it should be equal to A2. So angle B3 is equal to A2. Okay, to answer 8.2.1. So on 8.2.1, we're going to say that B3 tan chord theorem, right? Is that correct? Yes. B3, angle B3 is equal to angle A2. Let's keep on finding the angles that are equal to A2. Let's keep on finding those angles that are equal to A2. So now, when I look at this, angle A2, when I look at angle A2, which other angles again are equal to A2? So look at this other tangent here. Then this line is that chord. So this tells you that this angle is equal to A2, tan chord theorem. So this one was tan chord theorem. And then we also saying that A2, angle A2 is equal to angle C2, reason tan chord again. Right. So now when I go to angle T1, this is my angle T1. Right. So I can see that this angle T1, since this line here, it's parallel to that line. We can look at alternating angle. Look at this. T1, angle T1, it's equals to angle C2. Look at this. Both A2 and T1 are equals to C2. Remember I said when they want you to prove something, when they want you to prove that two angles are equal, you find all the angles that are equal to those angles. And if you find that there is a certain angle that is equal to both, then you can conclude. So the reason for this one, T1 is equal to C2, this will be alternate angles because BC is parallel to PQ. This was given here. So I'm going to conclude and say, since A2 is equal to C2 and T1 is equal to C2, therefore, we can conclude and say that angle A2 and angle T1 are equal. Right. And that's it for this one. We can move to the next question. Next question, 8.2.2. Prove that triangle ABC is similar to triangle TCQ. Okay, let me just try and clean my board. So you know what I'm going to do? I need to highlight the triangles that they are working on, they are referring to. Right. I'm going to highlight those triangles that they are referring to. Let me see. A, B, C, A, B, C. So this is my A, B, C. So this is the triangle they are referring to. They want us to prove that this triangle is similar to what? TCQ. It's similar to TCQ. Guys, when you prove that two triangles are similar, you just have to find angles that are equal in these two triangles, okay? Or sides that are equal in these two triangles. So you're going to focus only on these two triangles and tell us which angles are equal. Simple. So you just focus on these two triangles, find angles that are equal. Okay, so in this triangle, so when you answer 8.2.2, you need to tell the marker that I'm working in triangle ABC and triangle TCQ. Okay, so let's first look at this. Let me look at, I can start with any random triangle. Maybe let's say I start with A2. Remember, we just proved that A2 and T1 are equal. So A2 and T1 are equal. Then I'm going to write this down, that T1 is equals to angle A2. Then your reason is that proven. Why? We did this in the previous question. Then I'm going to look at B2 and try and see in that other triangle which angle is equals to B2. So when I look at B2, I don't think it's easy for us to look at that angle. But look at this. I need you to pay attention on this. Remember, this line is parallel to that line. So since they are parallel, I'm looking at a pattern here. Corresponding angles. Can you see? Corresponding angles. They form an F. Right, they form an F. So this angle C3 is equal to that angle Q. So angle C3 and angle Q are equal. What will be the reason? Corresponding angles, because BC is parallel to PQ, 100%. So now, since we have two angles that are equal, we can conclude and say, therefore, the remaining angles are equal, because sum of angles in a triangle, they should end up to 180 when you add them. So if I have an angle like this is 60 and this is 40, and I have another angle that has 60 and 40. So when we add this angle, they should 180. So this tells you that even these two angles are equal. So what I'm trying to say is that we can conclude and say angle B2 is equals to that angle C1. So then when you have three angles that are equal, the reason for this one, you can say these are the remaining angle. Okay, or if you don't want to say remaining angles, you can say the interior angles of a triangle. Then we can conclude and say these two triangles, ABC, is similar to triangle P. Oh, this will be to TCQ. TCQ. So these two triangles are similar. What will be your reason? Angle, angle, angle. Okay, that's your reason. Then you are done with the proof. Moving to the next one. 8.2.3. ABT is a cyclic quadrilateral. We need to prove that ABT is a cyclic quadrilateral. So I'm going to remove everything there, and then I'm going to try and do those points and see what kind of a shape I have there, and then we'll take it from there. So ABT from A to B. Okay, AB, and then from B to T. ABT what? ABTQ. ABTQ. So we need to prove that this is a cyclic quad. So how do you prove that something is a cyclic quad? What should you look at? You need to understand the properties of a cyclic quad. Number one, opposite angles of a cyclic quad are supplementary, meaning that when you add opposite angles, you get 180. Number two, exterior angle of a cyclic quad is equal to the interior angle. The opposite interior angle. I'm going to explain that. So if I have a cyclic quad like this, and this is my cyclic quad, and let's say I put an exterior angle, this part, it's equal to that interior angle. So if we can manage to prove that an exterior angle is equal to that, then this is a cyclic quad. So another way to prove a cyclic quad is that if you have a circle like this, and then you have two angles that are subtended by the same arc. So two angles that are subtended by the same arc, like this. Two angles subtended by the same arc, and maybe this is A, B, C, D. So angles in the same segment. If these two angles are equal, then we can conclude and say A, B, C, D is a cyclic quad. Another way to prove a cyclic quad is that opposite angles of a cyclic quad are supplementary. So if you add this angle with that angle, you get 180. So those are the things that you need to prove. Okay. Let me look at this, and then we're going to discuss how we can attack the question. So your focus should be on the diagram that it is in purple. So please make sure that let's first test this one and see if we can use this one. So this is what I'm going to first start with, because this one won't work. Why? Because you can see that other points that are outside of the circle. So this one won't work. And then let's just first test the exterior angle. So let me, if you pay attention, we have this angle here. Let me indicate my exterior angles first. So this angle here, that's an exterior angle of that cyclic quad. Another exterior angle, I think, is this one here. That's another exterior. So what I need you to do, I need you to focus on proving that B1 is equals to angle B1 is equal to angle Q. If you can prove that, then you're good to go. That's a cyclic quad. Another thing that you can prove is that angle C3, if you can manage to prove that T3 is equal to angle A2, then we can conclude and say this is a cyclic quad. So I'm going to start with B1 and see how can I prove that B1 is equal to Q. You see, that's how you attack the question. It's not like we always know the answer. We just have ways to find answers. That's how you do maths. Okay. So on this one, 8.2.3, on this 8.2.3, I'm going to say that when I look at this, I need to find all angles that are equal to B1. And if you look at the diagram, this is a tangent. So B1, the angle between a tangent and a chord, is equal to the angle subtended by that chord at a circumference, which is C3. So B1, angle B1 is equal to angle C3. Right, but remember, from the previous question, we proved that angle Q and C3 are equal, if you still remember. Where is that? I think we did, C3 corresponding angles. So we proved that angle C3 is equal to angle Q. Right. The reason for this one, the first one is tan chord. And the reason for the second one, you can say corresponding angles, or you can say this was proven. Proven, or you can say C3 is equal to Q because of corresponding angles. Right. So look at this. Both B1 and Q are equal to C3. Therefore, you can conclude and say that angle B1 is equal to angle Q. So you can see that since they are equal, this is going to be what? This is going to be a cyclic quad, because this is an exterior angle. This angle is equal to that angle. So it's an exterior angle of a cyclic quad. So therefore, I can say ABTQ is a cyclic quad. So you can also give them a reason why you arrived at that conclusion. You can tell them that the reason is that I have the converse theorem, which is the exterior. The reason will be the exterior angle. It's equal to the interior angle of that cyclic quad. Right, that's how easy the question is. I know I keep on saying that questions are easy. Right, so another way is that, guys, I just want to give you like an advice before we do the last question. Before we go and eat that 5 marks, let me give you something very important, guys. I know that we always rely on watching YouTube videos for maths lessons and also like uh, maybe watching live TikToks when someone is teaching math. Let me tell you guys how this works. You don't have to always rely on someone to explain something for you. When you get into YouTube, you want to see a video, you need to work on how is this person approaching questions. What are you learning from this question? Do I have a certain style that I use to approach questions? How do I analyze questions? You understand? Because all these things, they make sense. Why? Because I'm explaining this to you. But let's say I just give you the question without giving you explanation. Will you be able to do all these things? So when you come here, please make sure that you know the basics so that you are building from what you know. And also try to solve problems on your own, and you'll see that you will improve. Then when you come to the YouTube or TikTok or wherever where you watch lessons, you come with the knowledge you just want to build from the strategies that you use to analyze your question. You understand? So yeah, and let's just work on the last question. So what I'm trying to say, guys, is just basics are very important to understand the basics, because if you don't know the properties of a cyclic quadrilateral, you won't be able to answer 8.2.3. So let's say that I explain this part only. Then in the next exam, maybe they bring it like this and they want you to prove that ABC is a cyclic quad, or they just bring it like that. But when you only learned this method where we prove the exterior angle, you see, so you need to know all the properties, and you see that if this is not working, I can try and prove this one. If this one is not working, I can try and prove that one. I hope that you guys get my point. Okay, right. Okay, so I want to make space for the last question. The last question says that prove TQ is a tangent to a circle at TBC at T. So when they say something like that, I'm going to first, let me just clean my board, and then I'm going to write a line, or maybe we can create a circle on that points that they are referring to, then we'll take it from there. They want us to prove that TQ is a tangent to a circle TBC. So let me first draw my circle TBC. TBC, this is CB and T. So let's say maybe I try and put my ugly circle there on the diagram, and that's my circle. So they want us to prove that. Okay, I hope you guys understand how my circles goes. Okay, I think now I'm going to mess up these angles here. Okay, I think you understand what I'm trying to do here. Okay, that's my circle, right? So the question is saying that we need to prove that TQ, that this TQ is a tangent. So if TQ is a tangent, what should you prove? It's easy. You just have to prove that this angle, it's either you prove, let me show you guys. You see, that's exactly what I'm talking about. Knowing how to approach the question. When they say it's a circle at what? You draw the circle. Then you have your tangent. So when they say the, what is that? They said at TQ. So we can prove that this angle T1 is equals to B3, ne? Or alternatively, we can prove that, remember, this is a straight line. So this is the whole tangent. We can prove that T3, what is this? We can prove that T3 is equal to what? C2. I hope this makes sense. I hope you guys understand what I'm trying to do here. Right. I hope you guys understand that. So if we can try and prove that angles, then we are good to go. So let's work on something here. I think we are missing something from the statement. Okay, I guess I was wrong. All right. All right. All right. I'm still trying to think how I can solve this question. How can I solve the question? Because when I look at this question, look at this, I can see that the line TB, this line, it's equals to that line. And someone will be asking, how, say, why is that the case? If I have a circle like this, and I have a point like this and a point like this, and then we have a tangent drawn from the same point, the line drawn from the same point are equal. So these two lines will be equal, okay? Okay, because they are all drawn from point T. So since they are equal, this tells me that this angle here, the B3, is equal to angle C2. Let me go and write that information down. I'm not sure if this is part of my answer, but I'm going to put it down and then I'll see what I need to do next. You understand? You just have to write everything down. Tell the marker that, okay, so far, TB is equals to CT. So TB is equal to TC, and the reason tangent from a common point. We're going to say the reason is tangent from common point. Okay, good. Therefore, we conclude and say, therefore, this gives us an isosceles triangle. Base angles of a triangle B3 is equals to angle C2. Reason, you're going to say angles opposite equal side. Angles opposite equal sides. Right. So now, from that information, I'm just trying to find, you know what you need to do. Look at what was the aim. What was the purpose? Is to prove that this angle is equal to that angle, or this angle is equal to that angle. So I'm going to look at what is angle T1 equals to, okay? Or what is angle T3 equals to. Okay, so now I can say angle T3 is equals to what? Angle T3 is equal to angle C2. Reason is that this line is parallel to that line. So they form an alternate. And also, angle T1 is equals to what? Angle T1 is equal to angle B3. Same reason. Alternate angle. So this is alternate angles. This is also alternate angles. So now I can definitely conclude. Look at this. I have B3. Okay. Okay. I'm trying to say B3 and B3. You see, both of B3 are C2 and T1. Both of them are equals to what? What is this? Both of them are equal to B3. So can we conclude and say C2 and T1 are equal? So also we can say that B3 is equals to T1. We can conclude and say B3, angle B3 is equals to angle T1. Because when I look at this, I'm not sure if this makes sense, because if I can't understand what I'm saying, what about you on your side? What about you on your side? So let me just try work around these things, okay? We are saying that B3 is equal to C2, angle opposite equal side. So I think that if I can remove this part, maybe let's not focus on that part. Then now we are saying that T1 is equals to, you see, this is where I made the mistake. T1 is equals to angle C2. Okay, let me quickly fix it that T1 is equal to angle C2. If I don't understand what I'm saying on my side, what about you? Are you good? Okay, I hope this will clear the confusion, eh? Because if I'm confused myself, I just feel sorry for you. So someone might also lose interest and close the video. Okay, but remember, this is how it is. Learner, when you do math, you just don't get everything right. I get right. And also, when you do math, don't always rely on the memo. Just try to solve your problems on your own. So now we are saying that T1, angle T1 is equal to angle C2. That's alternate angles. So now look at this. Both B3 and T1 are equal to C2. Then I can conclude and say angle T1 and B3 are equal, which is what I was trying to prove, is that this angle is equal to that angle. So this is Stanford theorem. So since they are equal, I can say that TQ is a tangent. TQ is a tangent. And what will be the reason for that? Stanford theorem. Stanford theorem. Tell the marker, Stanford. I hope you guys had a great one on this one. I hope you really understand how to solve these questions. Please make sure that if there's something you don't understand, pause the lesson, try to make sense of whatever that you are missing and work this thing out. Okay, right. And that's it from this lesson. Okay, let's work on the next question and see what we can do from the next one. I'll see you guys on the next one. Thank you very much. Guys, I need to hear your voices. Since learners are not attending, I need you to talk with me, because remember, this is exam preparation. Eh?
Yes, sir.
Right, so now the reason I chose this question paper, I'll show you some of the questions that I'm interested in. I know that this question paper doesn't have stats. It's fine. We'll do a lesson on stats. I'll post the lesson on YouTube. So now, on this one, we're going to work through all this question. Hopefully, we'll manage to finish the question paper. I don't know. We'll see. Then this is question 1, and you guys already have the question paper on your side. So let's start wiki. So question 1, we are given a figure. I'm not going to read that. I'm just going to go straight to questions and attempt those questions. And if there's something you don't understand, please make sure that you ask question, you raise a hand, or you just unmute yourself, ask me whatever that you want to ask me. But today, guys, I can say which car am I using, but hey, it will be fast. I don't know. I'll be moving fast. So please make sure that you stop me. Né? Yeah. So now, today, I'm going to move. So when I look at this question, they say that calculate the length of AC. Give your answer in the simplest start form. I'm not going to waste time on that. Maybe we should just also open the, let's duplicate this test, duplicate tab. Then, is it, I want to post this on YouTube with the caption that says only for genius, or I'm not sure if it's right to say only for genius, because the speed that I'm going to move with today, if you don't understand the basics, how matter they. if you don't understand the basics. But when I see what the question is more complicated, you'll see that I'll try to move slow so that you guys can understand. Né? So this one, the first question, this is 2 marks. So I don't want to waste time on a question that is 2 marks. So I'm just gonna go straight and work on that. The length, which is the distance. And when I go to this, I can see that the distance formula is this formula here. Let me show you guys the distance formula. This is my distance formula. Make sure that you rewrite that correctly on your answer book, and then I'll go to the answer book and answer this question. So this will be your answer book. They'll definitely give you something like this. So this is the answer book, and look at the space that they give you. Okay, you see? These people. So now when I look at this, they are looking for the distance of AC. Okay, so I'm gonna say, first thing first, write the coordinates of A and C. So my A, the coordinates of A, that's -2 and -6. And then the coordinates of C, we are given the coordinates of C as 9 and 5. So when you calculated the distance formula, remember, I always advise you guys to name your point x1, y1, x2, y2, because the formula, when you write down the formula, what do you get? What is the distance formula? It will say AC is equal to the root of x2 minus x1 squared plus y2 minus y1 squared. Then I'm going to do my substitution. AC, my x2, that's 9. I subtract x1, but now since the x1 is negative, I need to put it inside the bracket. -2. Then this is squared plus y2, which is 5, minus y1, and it's also negative. So inside the bracket and square that part. This is squared. So you can just go straight, punch that on the calculator just to save time. Né? So AC, it will be the root of 9 plus 2. So I know that, and 9 plus 2, that's 11. So this will be the root of 11 squared plus 5 plus 6, that's also 11 squared. So when you punch this on the calculator, what do you get? Can someone please? You got 11 root 2, right?
Yes.
And they said, leave your answer in stat form. Don't punch that on the decimal, don't put it in decimal form. The next question, calculate the gradient of AC. So you go to your formula sheet, the gradient formula is that one. You write down the gradient, then you are good to go. So I already have the point there on top. I'm not going to rewrite those things. So the gradient of AC is the change in y, we divide by the change in x. So this is x2. We're going to say x2 minus x1. And I know that my y2 is 5 minus y1. Put it inside the bracket. Then I'm going to divide this by my x2, which is 9 minus into minus 2. The top part, that's 5 plus 6. And then 9 plus 2, which gives us 11 on top, 11 on bottom. This is just 1. Therefore, the gradient of AC is 1. Okay. So now, the next question says, determine the equation of AC. You see, we are still working on AC, but now we have the gradient of AC. If you still remember, the standard form of a straight line, AC is a straight line. Né? AC is a straight line. And if AC is a straight line, what do we do? AC is a straight line, and if AC is a straight line, it should be in the form of mx plus c. So, do you have the gradient of AC? Yes, we do have the gradient of AC. It's 1. Go and substitute that, then you get that the equation is just x plus c because the coefficient of x is 1. Remember, m is the coefficient of x. So when we substitute 1, we just get x plus c. The aim is to calculate what? The aim is to calculate that c. I'll go back on the diagram and look at, remember, this is the equation of AC. You can choose either this point or that point to find the corresponding, to find the value of C. So if I choose A, that's minus 2 and minus 6. So look at this. If I choose A, that will be, the coordinates of A is minus 2 and minus 6. So this is your X, this is your Y. So on the graph where there's Y, I'm going to put minus 6, it's equal to where there's X, I'm going to put minus 2 plus C. So the minus 2 comes to the other side. So that's minus 6, you add 2, you get that your C is minus 4. Take this C, substitute it back on that equation to find the standard form of the line AC. So the standard form will be X minus 4. So if you're not sure about your graph, you can go back and confirm. Look at this. AC, look at how this AC moves like. First thing first, it has the y-intercept there. So that y-intercept is at minus 4. But for you to confirm this, you can just say the gradient, if the gradient is negative or if, okay, the gradient was positive. If the gradient is greater than 0, your graph will look like this. And if the gradient is less than 0, your graph will look like this. It's a decreasing function. So for the fact that we got our gradient positive, you can see that we are on the right track. Any questions so far? You guys have any questions?
No, sir.
100%. Right. So when I move to the next one, let me look at what I have on 1.4. So 1.4, they say give a reason why AE is perpendicular to BD, and I expect to get that answer from this lesson. Hey guys, please, can someone please tell me? So give a reason why AE is perpendicular to BD. Look at the diagram. What can you say about that? Anyone, please? Why is the line AE perpendicular to BD? Why they form a 90 degrees? Because when they say perpendicular, they're trying to tell you that this is 90. But now why? What is your reason? Why is that angle 90?
Sir,
I'm listening.
can we prove it by saying the product of those two gradients will be equal to -1? Then if we get that it's -1, then we can say AE is perpendicular to BE.
So now, Mpo, look at this. I want to show you something. Mpo,
Yes, sir.
want to
Yes,
show you
sir.
something. If I go back to this, look at the mark allocation. It's 1 mark. Can we calculate the gradient of AE and then calculate the gradient of BD? Then say if we multiply these two, they give us -1 for 1 mark.
I didn't check.
No, I'm not fighting. I'm not fighting with you, but I'm trying to train you that when you answer some of the question, also look at the mark allocation. So now I'm asking you that, looking at that mark allocation, do you still want us to calculate the gradient?
No.
Because look at this. Can we calculate the gradient of BD? Because we don't have the coordinates of D.
No.
So that one won't work. So I need you guys to look at the diagram. Guys, take your time, look at the diagram and tell me why they are perpendicular. Because if we don't get an answer from this, and if this was my class and this was my school and I was the principal, I was gonna take you all back to Greek 9 if you guys don't give me an answer. But unfortunately, this is not my school. We are coming from different schools. I'm listening. Let's start with
Isn't it because it's a card?
Emike? I'm
Isn't it
listening,
because
Emishe.
like it bisects?
Guys,
Like, isn't it because it bisects?
I
Like with
can't,
the kite.
I can't hear Emishe. I'm not sure if it's on your side. I'm listening. What are you saying?
You still can't hear me, sir.
Emishe, I can hear you.
Can you hear me?
Yes.
I was saying, isn't it because it's like a kite and it bisects?
Exactly. It's a kite. Look at the shape. The diagonals of a kite, they bisect. It means that they intersect at a right angle triangle. Okay? That's why I'm saying that if you don't get this one, but unfortunately, this is not my school. You guys come from different schools, right? So the reason is that they are perpendicular because uh, the diagonals of a kite, they bisect. Right. Okay, so the diagonals of a kite, they bisect, or don't say bisect. Instead, you can say they intersect at right angle. They intersect at 90 degrees. Right. So, therefore, BE, it will be perpendicular to AC. Then BC, BD and AC are perpendicular. They form 90. Let's continue. Let's go to the next question. Thank you very much, guys. Mpo, I really appreciate your answer. Mpo, your answer is right. If we had the value of G and they were offering a lot of marks, we'll definitely go with that. Thank you very much. This is what I was teaching the Greek tense now, because I just came from the Greek tense lesson. I was teaching them that the gradient of the perpendicular lines, the product of the gradient is -1. Next question. Determine the equation of BD. The equation of BD, guys, look at the mark allocation. We can't just start by calculating the gradient. Né? We can first start by finding the gradient, but that's not what I'm going to do. I'm not going to first find the gradient of BD. This will take so much time, but I'm going to look at, we just said ABD is perpendicular to AE. Do we know what is the gradient of AE? Yes, we know. The gradient of AE is equals to the gradient of AC. Reason, collinear points. These are the points that are on the same line. They will have the same gradients. So this tells you that from A to E, the gradient of A to E is the same as the gradient of AC. Collinear points. This point and that point, they are on the same line. They will have equal gradients. Okay. Now, I know that the gradient of AC, which is something that we calculated on the previous question, it was 1. So the gradient of this is just 1. Can someone tell me, without making any calculations, what will be the gradient of BD? Anyone? What will be the gradient of BD?
Won't it be -1?
Exactly. It will be -1. Né? It will be -1 because if the gradient of BD, not BD, is that BD? Yes. If the gradient of AC is 1, the gradient of that one will be -1, because when we multiply the two, we need to get -1. So now that you have the gradient and they are looking for the equation, we should be in the form of mx plus c. So substitute in the gradient, y is equal to -x plus c. Then choose any point on BD. We can't choose D. We don't have the coordinates of D. We don't have a choice but to choose that E. They set the equation of what? BD. So we don't have a choice but to use that point. Okay, so I'm going to use B, which is 3 and 6, substitute and on that equation. So the coordinates of B, that's 3 and 6. Then if it's 3 and 6, you know what is your Y, you know what is your X. So this is my X, this is my Y. So this will be 6, it's equals to minus into 3 plus C. Therefore, when you solve, you'll get that 6 plus 3 is equal to C. Therefore, C is just 9. And what will be the coordinate? In standard form, you're going to take from this form, you substitute 9 and you get that this is Y is minus X plus 9. Is everybody with me on that? You guys understand what I did on that one? Are you all happy?
Yes, sir.
100%. 1.6. Let's say 1.6. 3 marks again. So 1.6 says that determine the coordinates of E. So you see, look at E. Guys, very important. We know that if this is 90, the diagonals bisect. So this line is equals to what? This line is equals to that line. I'm not sure if this will work now. Okay, so they are equal. But you know what I'm going to do? There's nothing I can do by that information. I think the best thing that we can do is to find a point of intersection, because we have the equation of BD, we have the equation of AC. This is the point of intersection between those two lines. Can we find the point of intersection? Just apply everything that you know, because you have to give nothing but your best. Are you all happy with the method that I want us to go with?
Yes, sir.
Should we find the point of intersection? So to find
Yes,
the point
sir.
of intersection, this tells you that if the equations were wrong, you're going to lose marks. You're going to donate the marks. So I need the equation of BD. I need the equation of AC. I need to substitute these two equations. This is AC, and this is the equation of BD. And I need to substitute those two and find the corresponding X value. Okay, so E, this is the point of intersection. Okay, and then if it's the point of intersection, I'm going to equate the two. It was X minus 4, equated that to minus X plus 9. I move the X this side, it's plus X, which gives us 2X. Then now the 4 to the other side, which is 9 plus 4, that gives us 13. Divide both sides by 2. Therefore, the value of X is 13 over 2. Right. So I need to find the corresponding Y value. So we have the X value, we need the corresponding Y value. So now the corresponding Y value, I can say that I can use one of these two equations to find, because it doesn't matter which equation you choose, you'll still get the correct answer. Y is equals to minus X plus 9, and then Y is equal to, where there's X, I put 13 over 2, and this is negative, we add 9. Therefore, what is the Y equals to? What is that on the calculator?
5 over 2.
You get your answer as 5 over 2.
Yes.
Right. So it's up to you. You can leave your answer like this, or you can write the coordinates of E as your decimal form. So this will be 13 over 2 and 5 over 2. Then if you do this in decimal form, what is 13 over 2 in decimal form?
6,5.
And then what about the Y coordinates?
2,5.
2,5. Okay, so the next one, 1.7. Determine with reason the coordinates of G for 3 marks. Okay, so now if they want the coordinates of D with reason, guys, look at this. I'm not sure if what I'm going to do here, you guys will understand. Okay, so this line is equal to that line. Okay, we can see that So I'm not sure the best way to do this. I'm not sure the best way to do this. But look at what I want to do. Let me just engineer the question. I'm going to fix this question here. I'm going to fix this question here. Right? This is 3. Right? Hey, Buffett, if you don't be creative, you know what is mtonyonyo? Do you have maybe someone what's bang Sepedi in the lesson? Is there someone who knows how to speak Sepedi?
It's me, sir.
Mpo, do you know what is mtonyonyo?
No.
At school, when they give you free food, I get at school, you guys, you go and get free food. The food that you eat at school every day, if you're not going to private school, of course. If you go to public school, there's food that they cook for you every day. We used to call that thing mtonyonyo, free food. So this is free marks. Look at this. If you are not creative, you're going to lose those marks. Now, and I know that if I draw a line that is parallel to the y-axis, this gives me this side to be 3. That point there to be 3. And I can continue with that line, which is still parallel to the line, to find what? To find the coordinates of D. I'm not sure if this will work, but it's fine. This is D. Now, I know that if I put this point here, and then let's do the same with this one. What was the coordinates of E? If you go back, the coordinates of E was 13, which is 6.5 and 2.5. Let's write the coordinates of E down. The coordinates of E was 6.5 is to 2.5. So this point here is 6.5. Right. Then I'm going to do the same with D right here. Right. So, you know what I'm going to do. I know that I need to find the midpoint of E. I'm not sure if this will work, but let me think about this. Now, let me think about this. And if you do have a way that we can answer this question, please do tell me the method that you want us to use. Okay, so when I think about this, I think that if we can manage to find the y-coordinate of if this point here, the distance from this line, it's 6, okay? And the distance for this line, it's what? 2.5. What is the midpoint of 6? What do you get when you say 6 minus 2.5? Guys, please help. What do you get? What is 6 minus 2.5? This is, yeah. What is 6 minus 2.5, guys? Please assist.
3.5.
You get 3.5, ne?
Yes.
Okay, so this tells me that if I cut this line here, the top part is 3.5. Okay? Let's do this. Can we take this? I think we're even going far. Let's take this point here. I'm going to take this point here and call this point maybe negative something. Okay, let's say this is the x is 3. Let's use this 3 to find the y-coordinate of D. If this point is on the same as that point, what do you get? On one of the equation, where there's D, I think the equation that we can use is this one. Let me check this one, guys, please. The equation of, I need the equation of BD. Which one was the equation of BD? Okay, from this equation, can someone please tell me what you get if you substitute your x to be 3? What do you get? No, is this the equation of BD?
Yes, it is.
Yes.
Okay, and what do you get?
So we can't hear you. You said we must substitute what?
Let me wait. If this is AC, this
Sir,
part, I'm listening.
I think I have a method for finding D.
Okay, I'm listening.
Sir, because you said BE and ED, they are equal.
Exactly.
It makes E to be the midpoint of BD.
Yes.
So, sir, we can use the midpoint formula to find D.
You think we can use the midpoint formula? You know, I think I agree with you, but if we use the midpoint formula, which one should we use, for the X or for the Y?
For both.
For both the X and the Y, sir.
No,
For
I
both.
don't. Listen,
I just did it and
listen.
it works.
I don't think the X will work, but let's try and see if both of them works. Né? So if you guys want us to use the midpoint formula, so we're gonna use this and that one, né? And then also that one. Okay? So this is like this. We're going to say the midpoint formula is like saying y1 plus y2 over 2. It's equals to, we need to find the y of D. Okay? Then what is your y1? The point of E, it was, what was this? 6.5 and 2.5, right? D is X and Y, and then Y1 is that Y of D. We add with Y2, which is 6 of B. Divided this by 2, this is equals to YD. This gives us the Y of D. Is that what you guys want us to do?
No, sir.
No,
I think she
it
means
gives us the midpoint, the X. Okay,
no, sir. I think she means the formula that says xm is equal to x1 plus x2 divided by 2 is to ym is equal to y1 plus y2 over 2. Where xm you substitute the coordinates of the midpoint,
Yes,
and then y you substitute the coordinate, the one coordinate that we have, which is b.
Okay, thank you very much. This is exactly what we are currently doing. I think the issue here is that this should give us the y of E, and this should give us the midpoint, which is the y of E. Okay, so when I do that, I think the issue here was the substitution. Let me just write this correctly and see. Okay, so if I do the substitution correctly this time, it's going to be y1, let me call B my x1, y1, let's call this my x2, y2. So my y2 is y of D, my y1 is 6. So this will be, I'm sorry, yes, what you are saying, guys, is it's 100% correct. So y of D, we added that with y of B, divide this by 2. This should give us the y, which is 2.5. Then this will be y of D plus 6. Y of D plus 6, it's equals to 4.5. Again, then the 6 goes to the other side. Therefore, what is y of D? What do you get? So this will be 4.5 with minus 6. What is the answer? What is y of D equals to?
-1.
-1. And then we're going to repeat the same process.
1 comma 5.
You got
Negative 1,5.
negative 1,5.
Yes, sir. You
Yes,
did a
sir.
mistake.
Okay.
Y D plus 6 is equals to 5, not 4,5.
Not for
Oh,
2 times 2,5
it's
equals to
5.
5.
Okay. Let me fix that one. It's 5, ne? Okay, so this will be 5, and then the 6 goes to the other side, which is 5 minus 6. This gives us minus 1. Then we repeat the same process. Y1 plus Y2, not Y1. X. Guys, since I'll be sending this on the group now, I think it's best if we stick to the... So this was x1 plus x2 over 2. This should give us the midpoint of 6.5. And then x1, what is x1, which is 3, is going to be 3. We added that with the x of g. So this will be 3 plus d. The x of d, this gives us 6.4, 6.5 times 2. What do you get?
13, sir.
13. Therefore, the 3 comes this side. This gives us the x of d to be 10. Then the other side we said y1 plus y2 over 2 is equals to 6.5. This was 2.5, and then this was like the y of d. We added that with 6. It's equals to, you guys said this is 5. Therefore, this gives us the y of d to be minus 1. Therefore, the coordinates of d was 10 and minus 1. So, you know, guys, I need to go back and try to check what was I cooking here. What was I trying to do here? Because I had a plan, a very good one. I just want to understand what I was trying to do here. Guys, can you please give me a second? I need to understand what I was trying to do, because I think I was on the, I'm not sure if I should say on the right track. Okay, I see what I was trying to do is it was going to be wrong. It was going to be wrong. Yeah, it was going to be wrong because I wanted to say D will have the same point as that one, which is total, that will be wrong. That was what I was trying to do. And I also wanted to use the distance formula when I got that as 3.5. I wanted to also calculate the other distance, but I think that was not going to work. Nah? Okay.
Sir, can I ask you something before we move to the next question?
Okay.
I think what you were trying to do, you were trying to say 6,5 minus 3, which was going to be 3,5, and then you add that 3,5 with 6,5 to give you 10 for the x coordinate, and then there's a point there which is C, it's 9:5, and you want to find the working the y coordinate. So you're basically going to say 9 minus 10, which was going to give us -1. I just forgot what kind of method was that.
And when I'm poor, you're smart. This is exactly what I wanted to do. That's why I said this is easy maths. I want to go back. You see, I had 3.5 here. I'm not sure how I can go back to that one, but already I'm erasing this. I had the 3.5 there. So now this is what I was trying to do, but it's fine. Ne? That's why I was saying this is easy maths. Ne? But it's fine. It's fine, guys. Let's just move to the next question. Huluki. It's fine. You know. Okay. When I move to the next one, they say calculate the size of ADC, which is 5 marks. Again, another issue. You see this type of questions. Okay, guys, on this one, I'm not sure how we're going to solve this one, but I will definitely work on this one. So they said that they want us to find ADC. So from A to D, from D to C. So we are looking for this whole angle then. So this is the angle that they are looking for. How can we find that angle? Maybe we can just, maybe, I don't know. I know that I can find the angle of inclination. I'm going to call that alpha. Another angle of inclination there. I'm going to call that theta. Guys, I'm still trying to understand how I can solve this question there. And then if I extend this line here, because I'm allowed to, I can extend this line as a straight line so that it can cut the x-axis somewhere there. Hey, where is that speed I was talking about? But it's fine, it's coming there. I think I said if the question is tough, that's when we reduce the speed. Okay, so when I look at this question, let's form this D1, D2, D3. And then we are still trying to find a best way to answer this question. And then let's call this maybe point M for MPO. Point M for MPO. And then now I know that angle theta, it will be equals to angle D1 plus D2 plus that angle M, exterior angle of a triangle. And then if I call this theta 1, I know that angle theta 1, when I added that with angle M, I will get angle D3, another exterior angle of a triangle. Let me stop here. Do you guys understand here? I'm not answering the question yet. I'm just finding the best way to answer the question. Do you guys see what I'm doing here? Guys, please tell me if you understand.
Then I don't understand, ne? But I have a suggestion. Ne?
Wait, Timpo, wait before you suggest them, because remember now I'm coming with something and then I'm going to forget what I was trying to do. Let me work out, then I'll give you a chance to suggest. Ne?
Okay, sir.
Because now I'm going to forget what I'm trying to do here. So now when I have this, I know that from this point, you know what I'm going to do first? Let me first calculate my theta and see what I can get to that theta. Let me first calculate my theta. So theta is an angle of inclination for the line BD. So I need the gradient of BD. And we already have the gradient of BD. What was the gradient of BD equals to? Do you have the gradient of BD?
It was -1.
-1.
Yes.
Okay. And then what is the gradient of CD? We need the gradient of CD. Do we have the gradient of CD? Or we need to first calculate the gradient of CD?
Yes, we have to calculate.
Okay, since I need the marks, I'm definitely going to do that. X2. Okay, and then Okay, so this will be my, hey guys, and then everything is divided by x2 minus x1. When we substitute that, oh, we can't find the gradient of CD. Oh, we have the point D was 10 and what? Minus 1, right? This is my x1, y1. This is my x2, y2. So this will be minus 1r. Come on, guys. How are we going to do this? The call will end in 15 minutes. You guys will have to rejoin using another link. It's fine. I'll give you the link. So this is minus 1 minus y1, which is minus 5 over, what is this? X2, that's 10 minus 9. So basically, the gradient of CD is minus 6. So if I have the gradient of CD, I can use that gradient to find my tan alpha. So the tan alpha, it's equal to minus 6, because the angle of inclination, we find it by saying the tan of theta is the gradient. So therefore, when you punch that on the calculator, you should have your alpha as what? Please don't include the negative. What is your alpha? What is the reference angle? In fact, what is the reference angle?
80,54.
80,54. Then what is 180 minus that? Say 180 minus answer.
99,46.
99,46. Are you all happy with how I got that theta, ne? So if the gradient is negative, you're going to say 180 degrees minus the reference angle. Okay, so this is my angle here. I have this angle down, and this angle is 99.46. That angle is 99.46. Okay. Okay. Let's continue and see where is this taking us. Let's find this angle here. Let me see. I'm thinking of doing something here. Guys, let me push this side, and then let me call this angle M1. Can we find angle M1? To find angle M1, we need to use the tan of angle M1. It's equal to the gradient of AD. Are you still with me? So the gradient of AD, do we have to calculate the gradient of AD again? Hey, you see? Y2 minus Y1 over X2 minus X1. So let's substitute. So this will be my X1, Y1, and then D is X2, Y2. So the gradient here will be 2, which is minus 1. We minus that into minus 2. Oh, no, not minus 2. It's minus 1 minus into minus 6. minus into minus 6. Everything is divided by y2, x2, which is 10, minus x1, which is minus 2. So the gradient of AD is just what is the gradient of AD? On top it's 5. This is divided by 10 minus 2. I think it's plus 2, which gives us 12. So the gradient of AD is 12. Therefore, can someone tell me what is angle M1? What is the tan inverse of that angle? You seem I was gonna forget the process that I wanted to do here. What is the gradient of that angle? What is the tan inverse of 5 over 12, guys?
22,62.
22,62. And then this angle is 22,62 degrees. And then now look at this. This angle, it will be equals to that angle, vertical opposite angle. So this angle here, it will also be 22.62. You see, I'm trying to move fast. 22.62. Okay, right. From there, I have this angle here. I have this angle. And how will that help us to solve the problem? How will that help us to solve the problem? Let's first find angle D1. I think we can get angle D1, and to find angle D1, we can use exterior angle of a triangle. You see now, guys, I think you can all see that I don't have an idea how to solve this, but the moment I start finding things, everything starts to make sense. Look at this. Look at that. Look at that. Look at that. You see? That triangle, this will be an exterior angle of a triangle, meaning that alpha is equal to the sum of angle D1 and that angle M2. So my alpha is what? My alpha is what is my alpha? 99.46 degrees. This is equal to angle D1. We add angle M2, which is 22 point. Therefore, this gives us angle D1 to be 99. You minus 22.62. What do you get? What do you get, guys? What is 99.46 minus 22.62? Uh-oh.
70.84.
Thank you very much. King now. 76.84. Guys, are you angry or I'm doing the long method? I don't have other method. This is what, even you guys, you can see that I'm cooking the method with you. Why never quiet? Why you don't punch a calculate or Lengelamona? So this is angle D, né? So now that I have angle D, what the fudge? Oh, I'm sorry, guys, your language. I need to cancel that one. Okay, so now this is angle D1, né? And this is going to be easy to find that D3 plus 2. We can use what? We can use what we call angles on a straight line. Wow, that was a long one. Therefore, the angle that they are looking for, which is ADC, it's equals to 180 degrees minus. This reminds me why I was the best at school when it comes to maths. 84 degrees. Therefore, what is A angle DC? What do you get? What is your answer?
103.16.
103.16 degrees. I think I need to open my calculator. Eh? I'm not sure if you guys are angry with me or already are tired. Should we end the lesson? Mpo, now it's your time to
No,
shine. Now it's your time to
No,
shine.
sir.
Eh?
sir, I got the same answer, ne?
Yeah? Now
But
it's your time to
yours
shine.
was I got the same answer, but yours, it's a long one.
Yo,
So,
guys.
for me to understand this, I went back to 3D trick, then I
True.
used cos rule.
I
Cos
think,
rule.
wow, the cos rule will need us to find the length of what?
Yes, you had to. Yes, I found the length first, and then I used barking. Barking. I can when the triangle is not a right angle triangle, you either use cos rule or sine rule. So since I was looking for what 3 sides and an included angle, I had to go to cos rule, and then I found the length and then substituted using that equation, and then I got a 103.16. Mara, since I had a negative angle, I had to add by 180 so that my it can be positive, and I got 103.16.
You know, deep down, guys, I want to do the cos rule, but I want to upload this question for the grade 11s. Oh, they do have the cos rule also. Look at what Mpo saying there. So in order for you to get the same answer as Mpo, you need to say this side, which will be your small c, and this side, which will be your small a. Then you use the cosine rule to find the included angle. But to use Mpo's rule, you need to use the distance formula to know the distance from AD and also the distance from DC. Then you solve for angle A. So I'm not sure, guys. Let's vote. Do you want us to go for cosine rule, or should we go to the next question so that you guys can try that on your own? If the answer is yes, we'll try it on our own. We'll go to the next question. But if you want us to do Mpo's method, we can definitely do that. What do you guys think?
Next question, sir.
Next question. Okay, Mpo, I guess Buenas Doctors and someone. Okay, guys, you can exit the lesson. I'll send you the link for another lesson. But yeah. Okay, wait. Don't exit yet. I want to understand something. Are you all on the private group lesson? Because I don't want to send the link one by one. If you are on the private, I think there's only one learner not on the private group lesson. It's Emission. But what about other you guys? Are you on the private group? If you are not on the private group, please tell me now so I can send you the link. Tell me your name. Are you all on the group? Okay. Eminatuena, I was talking to you today. I know you are not on the private group. So what about other learners? Is it only one learner? So if I post the link on the group, everyone will be able to join.
And me, Samus.
Yeah, and Amy feel when I'll never console. When you wake me up at 7, the reason I wake up early is because of you. Okay, so I guess there's only 2 learners not on the group. I'll post the link now. You can exit now. Question has to do with analytical geometry, and then yeah, let's see the best you can do on analytical geometry now. In the diagram, the circle, blah blah blah, we can see what they're telling us. It's what you see on the statement. And the first question says that they want you to okay, let's look at the question. If there's something we don't understand, or if we have any issues, we'll go back to the what is this? Can you guys hear me? I need someone to unmute. Tell me if you can hear me, and tell me if you can see the screen. unless if you can hear the screen, it's fine. So can you hear me, guys? So, guys, can you hear me? Oh, Jesus. I forgot to unmute. Guys, I've been talking to myself. Can you hear me? I forgot to unmute myself. Can you hear me? Hello, can you guys hear me? Please unmute. Tell me if you can hear me. And you can see the screen also.
We can hear you.
Okay,
Yes,
so looking at this question, I'm not going to read the statement. It says that given the radius of the circle is 5 units, show that B is 5. Where's B? Okay, so the coordinate of B is the y of that point, and they want us to show that B is 5. And you know what I'm going to do when I have this type of a question? First thing first, write down the standard form of the equation. Okay, so to answer this one, I know that the standard form, this will be question 2. The standard form of the equation will be x minus a into y minus b, and then, okay, x minus a, and this is squared. We're going to add y minus b. This is also squared. We equate this to r squared. That's the equation of, that's the original equation. So the center there is 2 and 2. So I'm going to substitute. I have a and b as 2 and 2. So when I substitute, I get x minus 2 into, why do I keep saying into? X minus b plus y minus 2 squared. It's equal to, the radius is 5. This gives us 25. So now they said that we need to find that value there. I know, guys. See. Okay, so they want us to find the value of b. We need to substitute this coordinates. T is minus 2 and b. Né? So if I substitute t, which is minus 2 and b, this is my x, this is my y. On the equation where there's y, you put b, where there's x, you put minus 2. So this will be minus 2, this is squared, plus b minus 2, which is squared, is equal to 25. Then do what you do best, solve this question. So minus 2, that's minus 4. Minus 4 squared, that's 16. So this will give me 16 plus b minus 2, which is squared, and this is equals to 25. The 16 will go to the other side. I'm left with b minus 2. This is squared, it's equal to 25. I'm going to minus 16. Wow, this is good. This is 9. B minus 2, this is squared. Then I'm going to square on both sides. Therefore, b minus 2 is the root of 9. It's plus or minus 3. This gives us b as minus 2 to be 3, or b minus 2 to be negative 3. So that this one comes this side, b is equals to 5, or b is equals to minus 1. B is not equal to minus 1. Why? When I look at this, b is in quadrant 2. The y coordinates are positive. Right, b can never be minus 1. Therefore, the final answer, we showed that b is 5. Guys, this is the speed that I was talking about. Let me pause here to see if you guys have any questions so that I can also keep my room warm. I just want to switch on the heater. Okay, so please, guys, do you have any questions?
No questions, sir.
Okay. We're good to go. All right. What is the next question saying? I just want to have this heater on because I can see that is starting to be like yes. Okay, get it. So now let me see the next question. The next question says, determine the coordinates of K. Okay, so this is my point K. We need to find the coordinates of K. So when I look at this, already I know the x of K. Né? Already we know the x of K, because this line is parallel to the y-axis. They will have the same x as M. So already we know that K is 2. What about the y? Look at this. From this point to this point, the distance is 5. Yeah, the distance is 5 because we just said the equation is the radius is 5, and then the radius is 5. Okay, so the distance, what was that question saying? Given that the radius of the circle is 5, and then so if the radius is 5, we need to find from this point to that point, it will be 2 because of that 2. So from this point to that point, it will be 3. Okay, so the distance is 3. So this gives K to be negative 3. Are you guys happy with how I got that point?
Yes, sir.
100%. So the coordinate of K, this is 2 and negative 3. The next question, the equation of the tangent LTP in the form ymx plus c. They want us to find the equation of the tangent LTP. So when you look at LTP, to find the equation of that tangent, I think, or I believe that we're going to have to find the gradient of the radius. We'll have to find the gradient of the radius. Do you guys agree with me on? For sure, you guys are already doing the question. So first thing first, I'll go to my answer book and I'll try to find the gradient of, I'll first find the gradient of MT, which is the radius, the gradient of from M to T. Let's find that. We need the gradient of M, T. And the coordinates that we need to use is the center. What was that center called? M, which is 2 and 2. And then we are going to T, which is, B was 5. The other coordinates, it's minus 2. No, what was B? Show that B is 5. So this will be 5. So when I have it like this, I know that I need to name x1 and x2. So this will be my x1, y1, x2, y2. I need to give you guys time. Can you please tell me what is the gradient? What do you get? All right. So someone said something. What was the gradient? Guys, someone said the gradient. What did you say?
Negative 3 over 4.
Oh, okay. So when you do the substitution, this will be y2, which is 5, minus y1, 2, over minus 2 minus 2. Therefore, the gradient of MT is equal to minus 3 over 4. Thank you very much. So now that we have the gradient, we said without wasting time, we need to find the reciprocal. So the gradient of the tangent, what will be the gradient of the tangent? The tangent, it should be the reciprocal of that with a different sign. Therefore, the gradient of the tangent is equal to, we interchange that. It's going to be 4/3 without the sign. So that you have the gradient, use the equation y is equal to mx plus c. You just have to substitute. Y will be the gradient, it's 4/3 x plus what is c? We need to first find c. Which point can we use? We only have that t. So we need to substitute t to find the point of c, the value of c. So where there's y, I'm going to put 5. And where there's x, let's put -2 plus c. So we need to solve this and tell me what is c. So basically, the answer that you get there, you move it this side, it will be positive. So it's like saying -8/3. It comes to the other side, that will be 5 plus 8/3. What is the answer? What is c equals to?
Seven over 2.
You got the value of c as 7/2. Guys, let me just open my calculator. I think since you guys can see the screen, I can just open my own calculator because nkare akitsorela or young, but it's fine. I get it there. This is our last math lesson. I'll see you on physics. So this we said is going to be, well, when I go to calculators, we're going to waste time. This is 5 plus 8/3.
So I got 23/3.
5 plus 8/3. (23/3). Guys, when I open the calculator, I'm going to waste time, and we don't want us to waste time. So this will be 23/3. When you see that I'm going to use a calculator, when you see that I'm about to open a calculator or I'll need a calculator, you prepare, you punch that on the calculator. Then you give me the answer. That way we'll move fast. Plus 23/3. So that's the equation. We're done. We go to 2.3. 2.2.3. Calculate the area of LPK. They want you to find the area of LPK. So now, when I have this type of question, LPK, I'll go to my answer book and try to understand which triangle are they referring to. The bigger one. Okay, this is the triangle that they are referring to. Okay, this is the triangle LPK, the area of that triangle. So this tells me that we need to find, we know that, okay, this is not a right angle triangle, but we can make it to be right angle triangle so that we make a height, the line that will be perpendicular to that one. You see, this is 90. Therefore, the area of that triangle will be half base times height. So the base, it will be, maybe I can call this O for Onalena, O for you. Then this can be area is equal to the base times, what is this? Area is equal to the base, which will be the length of AO multiplied by the height, which will be OL. So the aim is to find the distance AO and OL. So how can we do that if we don't know the coordinates of O? So we know that O will have a common X value as 2 with M. It will have the same value with M. And then we need to find the corresponding Y value. But look at this. If we can find the value of P, the Y value of P is the same as Y value of O. Can we do that? Let's find the coordinates of P first. So the best thing that we can do to find the coordinates of P, I'm not sure if you guys have a plan or if we have a plan. So now what I'm going to do is that, look at this point here. Look at that point. This point, it's S. What are they saying about S on the statement? What are they saying about S? So S is the midpoint of PK. So since S is the midpoint of PK, this is what I'm going to do. S is the midpoint of PK. So if S is the midpoint of PK, we can find P using the midpoint formula, because already we know that the coordinates of K is 2 and minus 3. We can definitely find that P using the midpoint formula. I'm not sure if this, yes, this will definitely work. So the X coordinate of P, when we take the X of P, we add that with the X of K. We need to divide that by 2. The answer should give us the X of S, because it's the midpoint. So to find the corresponding Y value, when we take the Y of P, we add that with the Y of what is this? K. We divide by 2. This should give us the Y of S. Okay, I hope you guys are still with me on that. Né? So what I'm going to do, I just have to work this thing out and say X of P is what I'm looking for. I'm going to add this with the X of K. So the X of K is 2. This is divided by 2. We equated this to the X of S, which is minus 4. So this will just be X plus P. Okay, it's minus 8 is equal to X plus 2. Then the 2 goes to the other side, which gives us minus 6. I'm not sure, not minus 6 guys. X plus P. I don't know why this SP Pen keeps on doing this. Okay, so this will be the X of P. I'm gonna add 2, multiply both sides by 2, which gives us minus 8. And then the 2 goes to the other side. This gives us the X of P as minus 10. Did we do this correctly? Is this right? X of P, it's minus 10. Guys, are we right to do it like this? Okay, then we're gonna move and do for the other one. Ne? So this will be Y of P, which is minus 6. Y of P, we're going to add that, guys. Y of P, we're going to add that with the Y of K. We said that this will be divided by 2. The answer should be minus 6. So this will be YP, it's what we are looking for. Then we add YK. And YK, it's the Y of K is minus 3. This is divided by 2. It's equal to minus 6. Then Y of P will be minus 12 plus 3. It's minus 12 plus 3. Because I say 2 times 6, that's minus 12. The 3 goes to the other side. So the Y of P is just negative 9. So the coordinate of Y here is negative 9. Okay, so if this is my coordinates, what I'm going to do from this point, I have the coordinates of P. This gives me O to also be negative 9. Now that I have O, it's easy for me to find the distance. I know that the distance from this point, from OP, the distance of OP, it will be equals to 9 units. And the distance of, what was that? OPLO. The distance of LO, that will be, we know that from that point there, we need the coordinates of L. You see, this is far from being over. We have the coordinate of L there as what is the coordinate of L? We have 2, and then we need to find the Y. How can we find the Y? I think we can use point of intersection. Né? What was the equation of that tangent? So I'm going to use the equation of the tangent to find the point of intersection, because it intersects with the line x is equals to, it intersects with the line x is equals to 2, because it's a straight line. So the equation of that line is x is equals to 2. So on that equation, where there's 2, we can just substitute that to find the corresponding y value. So what I'm going to do from this point, I'm just going to substitute that. Let's substitute on that equation, the one that we got. We know that the equation of a tangent, okay, we know that the equation we just calculated the equation of a tangent to be y is equals to 4 over 3x plus 23 over 3. So this will be 4 over 3x plus 23 over 3. So where there's x, I'm going to put 2. It's like saying this is the point of intersection. This is the point of intersection. Or I can say I need f at 2. Where there's x, I put 2 to find the corresponding y value. So this is 4 over 3 into 2 plus 23 over 3. What do you get? Please assist with the calculator. What is that on the calculator?
10,33.
What is it is 10,33. What do you get in fraction? Just say SD to go back.
31,3.
Okay, 31,3. So if this is 31,3 and you said it's 10,33, né? So the coordinates here, now look at this. We know that if we add, this is from that point there, going up. So if that's the case, we need to add, it's from this point here going up. So this length here, it's that 31,33. So we need to add that 3. That y coordinate. Don't say plus minus 3. Remember, we're working with distance. We add a 3 to find the distance of what? LK. So the distance of AK, therefore LK will be, we need to take that 31 over 3. We add 3. So this will give us what?
40 over 3.
Thank you very much. We have some gentlemen in the lesson. At least 40 over 3. Nah? Hey, 40 over 3. So now, when it's like this is the distance of LK. So all protocol reserved. Now we're going to say this is the distance of LK. It's 40 LO. Why did we have? This is the distance of Hey guys, am I missing something here? What's going on? Hey guys, what's going on? Because look at this, we still have KO. We still have KO. Oh, that's the base, yeah? And this is even total wrong, because remember, the 9 units is from this point, this point, it's 9, then we need to add that point, which is 2. So it should be 9 plus 2, which gives us 9 plus 2. What do you get when you add the 2? we get 11. So this is not 9 units, but it's 11 units. And then now we still have to add that part. Can we add that part? Because this is like the distance, the base times the height. Guys.
So,
Oh no, we don't have to add that part, ne?
Ranier, whoa. You said 9 instead of 10.
I said what?
I said 9 instead of 10.
9 instead of 10.
Yes, by P.
Oh yes, it's 10. It's 10. Because we are looking at the x values, ne? Thank you very much. How can we take so much time to solve this question paper? Why? This is I think I do understand why. It's not like I'm recording the lesson. Pella, when you record the lesson for YouTube, there's no one asking questions. You don't ask anyone if they understand. You just do your mistakes and move on. Life goes on. So this is 10 plus 2, which gives us 12. So this will be 12. Don't worry, I'm going to rewrite this correctly. So AO is 12 units. So this will be the half of 12 times OL. I'm not going to add that other part. I'll explain why. Ne? I'm not going to add that other part. I'll definitely explain why we should not add the other part. Ne? So it's like saying this is OL, which is 40 over 3. What do you guys get? What is your area when you punch that on the calculator? Let me just open my calculator.
It is ufumano 80 for nini?
You got
80.
80.
Yiwo.
Okay. This will be 40 over 3 ish. Guys. Half into 12 into 40 over 3. $80. Thank you very much. Ne? So this will be 80 units. So this is 80 units. Okay, so guys, I just want to rewrite something. The reason why I'm not adding this part, and I'll stick to my story. If I'm wrong, I'm going to correct this when I upload the lesson on YouTube. So if you can look at this part, it's like saying I have a triangle like this. Ne? I have a triangle like this, and I'm looking to find the area. This is not a right angle triangle. So this is my base. I'm going to create the height. So when we create the height, we find the area. We don't count this part. We only substitute that part. I'm not sure if you guys still remember. Come on, Paul. Are you with me on that? Do you agree with me?
Yes, sir.
Thank you. Thank you. That makes me feel better, né? Because at least this shows what I'm doing is right. So what I'm trying to say is that the issue is that, guys, when I teach, I don't use the memo. I don't like A, B, C. Right. Okay, it's fine. Let's move to the next question. Né? That's why I make so many mistakes, because I don't prefer to work with the memo. Because on a memo, whoever made the memo is the same person. It's not like this memo was made by a machine. If someone can do this, and then what's wrong with us? We can also do this. Look at this. Another circle with an equation is drawn. Determine with an explanation the value of n for which the two circles will touch each other externally. So if they say the two circles will touch each other externally, first thing first, remember the equation of the first one was x minus 2 into squared plus y minus 2 squared, which is equal to 25. So the center of the first circle, it will be 2 and 2 with the R5. Now the center of the second circle is 2 and n with the R5. Look at this. The only common thing is R. Then what I'm going to do, I need to find the distance between those two circles by adding the radius. Okay? Both the distance between them, it will be the distance between the centers. You add the first R with the second R. I think I did explain this on YouTube. If you can go to my lesson, you'll understand what I'm referring to on this one. So now the distance will be 10. When you add the 2, what do you get? You just get 10. So this will be 10. Distance is 10. And now if the distance is 10, how is this going to help you? This is going to help you because both of the centers, they have something in common. What is that?
The radius.
No, we did talk about the radius. Now, what they have, another thing they have in common is 2. So this tells you that if they have something in common, we know that both centers have x is equal to 2. So the absolute value of those one, hey, if you're doing caps, now you understand why I'm saying, oh, AP Maths. If you do AP Maths, you'll understand what we mean about the absolute value. So the absolute value of that and the difference between that one, where is it? You see, let me not put it like this. So when I take n and subtract whatever that they have in common, I will get that distance of 10. So the absolute value, it's either is 10 or it's minus 10. So when we write this and say the absolute value is 10, this will be n minus 2 is equal to 10, or n minus 1. N minus 2, it's negative 10, because we are talking about the absolute value. So n will be, the 2 goes to the other side, which gives us 12, or the value of n will be 8, minus 8. Okay, I hope you guys understand that part, ne? Okay, so now, this one, the reason for this one, you can say that the sum of the radius, this will be the sum of the radius. And then the center of the two circles, they lie at the same vertical line. Why? Because of the x is 2. So the x and 2 tells you that they lie at the same vertical line. And that's it for this one. Moving to the next question. Trigonometry. Now we are about to have some fun. We're going to move fast now. Ne? So, yeah, you'll see when we're going to move very, very fast on this one. Simplify the following expression to a single ratio for 6 marks. Let's start with the first one. I'm just going to rewrite the equation on the answer sheet, and then we'll start working on it. Okay. I need you guys to give me a second so I can change. Okay, so we are given a trigonometric ratio that we need to simplify, and it goes like this. The first one is the cos of 90 degrees. Then we add x. This is multiplied by the sine of 540 degrees plus x, divide that by tan of x minus 180 degrees. This is multiplied by the cos of negative x. So on this question, we need to do the reduction formula, and I think we're going to get 1, 2, 3, 4 marks for reduction formula. Let's dive into the question. So the first one, I'm going to use the Cartesian plane. Now, if this is 0, this is 360 degrees. This will be 90. this will be 180, this is 270. So look at 90 plus. We are in quadrant 2. So the 90 degrees plus theta is in quadrant 2. How is cos in quadrant 2? Negative. So this changes from negative, from cos to sine. Because of that 90, the cofunction. So this guy here is negative the sine x when you reduce it. Let's go to this one. In which quadrant is 540? So you can just go to your calculator and do this. Go to your calculator and say 540 minus 360. I want to check something what I get when I minus 360. So this gives me 180. So if it gives me 180, you know what I'm going to do? Because I don't think it's going to be easy for us to say which quadrant is that guy. So if it's 180, I'm going to say 360 minus that is 180. So this will be 180 plus x. Okay, so this 540, we can write it as 180. And then this will become 180 plus x. Okay, so let's reduce the top part. Let me write what we have so far on the top part. The top part is the cos, okay, negative the sine x, and then we know that the sine of 540 degrees plus x, we can write that as the sine of 180 plus x. Then let's do the reduction formula for the 180 plus x. This is in quadrant 3. 180 plus x is in quadrant 3. Therefore, sine is negative. This will be negative the sine x. So the top part is negative sine x, which is multiplied by negative the sine x. I hope you guys understand how we got that. We have 2 marks so far. Then the tan of x minus 180. Let me work on that. The tan x minus 180. I know that some of you already know which quadrant is that, but let me ask this to those who don't know how to work with negative angles. So I'm going to take out that negative as a common factor. This leaves me with x minus, this leaves me with 180 minus x. When I take negative out as a common factor. So this will give us 180 with minus x. So if you say 180 minus x, what do you get? The negative comes outside. We left with the tan of that 180 minus x. So 180 minus x is in which quadrant? Quadrant 2. How is tan in quadrant 2? Negative. So this will be negative the tan of x, which is multiplied by negative, which is just positive tan x. So this one, it will be the tan x. By writing tan x, you have a mark. The cos of this is in quadrant 4. Negative x, that's in quadrant 4. How is cos in quadrant 4? Cos is positive. Therefore, this will change into positive, the cos x. Okay, let me work the top part and see what I have so far. So the top part is going to be, or maybe let's just first change and say this is sine x times sine x, because the negative cancels, and then sine over cos will replace the tan. This is multiplied by the cos. So now the cos cancels, and this will leave me with the sine x over, the sine x over the cos, over sine x. Over the sine x. So the sine x cancels the 1 sine x on top, and this leaves us with an answer of sine x as the final answer. Do you guys have any questions on that? No questions. Are you all with me? Are you guys still with me?
Yes.
100%. Okay, let's look at what we have on the next question. They say that given the cos p plus q, it's equals to that. They want you to use the above identity to express cos 2p. So I'll explain the first part of this side so that you can understand what is going on. So they are saying that if I have a cos and I'm adding 2 angles, which is this, I can write as the cos of P plus P, because I know that 2P is the same as P plus P. They say I can write this as the cos of the first angle, which is P. So this will be the cos of P times the cos of the second angle, but this side, the second angle is still P. Then minus the sine of the first angle, which is P, and then the sine of the second angle. This side, the sine of the second angle is still P. So this P here, it's representing that Q. So this P, where there's P, where there's Q, you just put P. Simple. Then you take this, you solve. Let's go and work on that. Né? Let's go and work on that. Okay, so first thing first, we know that we said we're going to have the cos of 2P, which can be written as P plus P. And then we said that we can just equate this to be, okay. We said we can equate this to be equals to the cos P times the cos, is the cos P times the cos P. Then we minus the sine P times the sine P. Okay, so from this I can just work this thing out. Cos P times cos P, that's okay. Let me go back to the statement. They said in terms of cos P. So your answer should only have cos P. Let's go. So this is cos squared P minus the sine squared P if I multiply the two. So now they said in terms of cos P, I need to get rid of that sine squared P, because if you still remember the identity, we can replace this as, this will be the cos squared P minus into, we can write this as minus the cos squared P. So multiply out the bracket by that negative. This leaves us with negative 1 plus the cos squared P. So when I have it like this, this will be, these two are the like terms, which gives me 2 of those cos squared P minus 1. This is an identity, né? No, is this an identity? Oh, this is cos 2P. This is the cos 2P. Wow, this is good. So cos 2P is equal to that. Even in identity, the cos 2P. So now they're trying to show us where's the cos 2P coming from. It's fine. Are you all happy with that? You guys understand?
Sir, can I ask?
Okay, I'm listening.
On the second step, we found it was cos squared P minus sine squared P. Doesn't it also bring you back to that double angle? So that
Oh,
step
like
can
you mean when we move from this straight to that one?
Yes.
Because we know the identities.
Yes, cos squared from the second, I can say you wrote, I mean the second step was cos squared P minus sine squared P, ne? And then for me I was like, this also gives us a double angle as well, which is cos 2P as well. So if nkebe o jikile ka step se sa bobedi, e be ka se be enough.
I don't think it's going to be enough, because looking at the mark allocation, this is 4 marks, né? So I think what they're going to do, they'll give you the 4 mark for the mark for being able to substitute that P, né? On the formula that was given again. Then boom,
Yes.
then you have another mark for this one. So there's 1 mark shorting. If they give you a mark for that, then what will be the other mark for? Look at my step. What will be the other mark for, if you think about it? Substitution. To change this, because they're trying to show you that, because now when you they're trying to check if you'll be able to change this into 1 minus the cos squared P, because what is the reason of changing that? The reason we are changing is that the examiner said the answer must be in terms of cos B. So they want to see if you'll be able to change that sign. So if you use the identity, you lose a mark for something that they are testing on that question. You get it there? Did I answer your question?
Yes, sir.
100%. Question 3. Yo, guys, I need a favor, ne? Tell me what you think. Ne? Guys, I'm thinking that we do 2 hours instead, then you guys will get. When are you writing?
Friday, sir.
This Friday.
Yes, sir.
I don't want to see you guys during the week. Yes. I was saying we do 2 hours, then you'll get 1 hour. Maybe if you guys will be available Thursday morning, we do 1 hour that Thursday morning. I don't know what you think. Think about it, ne?
Wait, so sir doesn't want to see us during the week.
Sir,
Because the call will end now. Let me check. What time is it?
No, sir, I was asking, so are we having no lessons during this week, upcoming week?
You saying?
I was asking, sir, if we are not having lessons this upcoming week.
No, now when are we together, ne?
Oh.
Yeah. Guys, the session is going to end now. Okay, it's fine. I think now there's many questions. Okay, ladies and gents, let's see what we have on this question 4. This is from a past paper. So now please make sure that before you start with the lesson, pause the lesson, read the statement, make sure that you understand everything on the statement. Make sure that you also go through this diagram. Let's just go straight to 4.1. On 4.1, they want you to calculate the value of theta. Look at this. What is theta? What is this theta here? That theta is the angle of inclination. So how do we find the angle of inclination? This is the angle of inclination, and what is your equation? It's AB. So we need to know the gradient of that AB. So I think it's best if we highlight that part. So in order for you to calculate angle theta, you're going to know you need the gradient of AB. So now we need to calculate the gradient of that AB. Then we're going to use the formula y2 minus y1, and everything is divided by x2 minus x1. So now what I'm going to do now, I need to write down my points. So look at this. This is A, and the coordinates of A are 4 and 2. And then let's list the coordinates of B, which is minus 2 and minus 1. So from these coordinates, you can see that A is the first point. I'm going to call this my x1, y1, and B, it's my second point. This will be my x2, y2. Please, why are we naming our points? Because we don't want to make any mistakes when it comes to substitution, okay? We don't want to make any mistakes, because if we make mistakes, we're going to lose marks. So now when I substitute, you check what is your y2, it's -1. So this will be -1. Then we need to subtract y1, which is 2. So this will be -2. Everything divided by x2, which is -2. We subtract x1, so we're going to subtract 4. So when you work this thing out, you can just say on top you have -1 and -2, which is just -3, the top part. So this will be -3 divided by -6. So I think everyone can agree with me that the negative will cancel. Therefore, what is the gradient of AB? I'm just going to move my problem down here and say the gradient of AB will be equals to what? It's 1/2. So now when you calculate the angle of inclination, this is how it works. Né? This is how it works. We're going to say the tan of theta, it's equals to the gradient of that AB. Then we know that the gradient of AB is just 1/2. So the tan of theta is equal to that. So to find theta, you just have to say theta is equals to the tan inverse of that gradient, 1/2. Then you punch that on the calculator, you'll have your angle theta. So the tan inverse of 1/2. Let me also put this on my calculator. Let's see what we get. Okay, so now the tan inverse 1/2, this is equals to 26.57 degrees. So now how do they mark this question? So you're going to get a mark for the correct substitution for calculating the gradient, and another mark for finding the gradient. Then the last mark is for the final answer. That's how they mark the problem. So let's look at 4.2. I'm just going to work on 4.2 this side. Né? So on 4.2, they say determine the equation of the line that is parallel to BC passing through A. Okay, so what they are trying to say is that if this line here is my BC, I need to create a line that is parallel to that BC, and the line should pass through point A. So this is the equation that they want us to find. So we need to write our answer in that form of y equals to mx plus c. So now let's work on this. What do you know about parallel lines? Parallel lines have equal gradient. So now maybe we can just call this, let me see, what can we call this line? It's fine. There's no need for you to name the line. So what we can do is just first thing first, we need to find the gradient of BC. So we need to find the gradient of BC using the formula y2 minus y1, everything over x2 minus x1. So I need my point B, which is -2 and -1. And let's see what we have on C, -6 and 7. Okay, so what is my x1, y1? I always like to name my points so that I don't make mistakes. y1, x1, y1, x2, y2. So now when we do the substitution, we know what is my y2, we know what is my y1. So my y2 is 7, so this is 7 minus y1, which is -1. So I'm just gonna save time because I know the negative will cancel. So on top I'll just have 7 plus 1, everything divided by x2, which is -6. Then we minus into -2, which is positive, so it will be -6 plus 2. Please make sure that you pause the lesson and you go through that. Né? So the gradient of AB, on top I have 8, on bottom I have -4. So it's 8 divided by -4, which is -2. So now This is the gradient that we need to use. Why do we need to use this gradient? Because remember, when lines are parallel, they have equal gradient. So this tells you that the gradient of this line that we are looking for, we're going to use -2. Right, so the formula that we can use the formula. There are two formulas that we can use. The first one is y minus, we can say this is y minus, let's call this x1 and equate this to, I'm not sure, but let's not use this formula. Maybe someone might be confused. I'm very sorry about that. But now let's just stick to the original formula. Okay, let's use the formula that says y is equals to mx plus c, meaning that where there's the gradient, we need to substitute -2. So this will be y is equals to -2x plus c. Now we can choose any point between, we don't have to choose any point because we only have one point on that line, which is A. So we're going to sub in point A. Look at what we have on point A. It's 4 and 2. So we need to substitute 4 and 2. This is your x, this is your y. So now where there's y, I'm going to put 2. This is equal to -2 into where there's x, I need to put 4. Why? Because we are looking for the value of c. We need to calculate for that value of c. -2 times 4, that's -8. So the -8 will come to the other side to be positive. So this will be 2 plus 8, then it's equals to c. So if we conclude c is 10, what is the equation of the graph? We need to take it and substitute it on that. So y is equals to -2x plus 10. I hope everyone understands how we got the equation of the line that is parallel to BC. For the fact that we see the word parallel, we know that parallel lines have equal gradients. So we can, because now for this line, we don't have enough information to calculate the gradient of that line. The gradient of this line, we don't have enough information, but we are told that this line is parallel to BC. So we can use the gradient of BC to find the equation of that line. I hope this makes sense, and I hope everyone is happy on how we calculated the 4.3 problem. Okay, so now ladies and gents, let's move to 4.3 and see what we need to do on that 4.3. We are given that the line BD is y is equals to 2x plus 3. So this line here is going to have the equation y is equals to 2x plus 3. Okay, calculate the coordinates of D. And which one is the coordinates of D? They are looking for this point here. Guys, look at this point. This point is on this line BD, and the very same point is on that line CA. So can you see that point D is the point of intersection between those two lines? Is the point of intersection between those two lines. And look at how many marks are we working on. 5 marks. So the marks tells you that, buddy, you need to do the work. You need to work. So now, how do we calculate the point of intersection? We need to have the two equations of those lines and equate them, solve for x. The answer that you get, you're going to substitute to one of the equation to find the corresponding y. So now to find the x value of D, we need the equation of these two lines. Already we know that BD, the equation of BD is y is equal to 2x plus 3. It was given. I'm happy with that. So now the aim is to calculate the equation of what? AC. So we need to calculate the equation of AC, and we can put the equation of AC in the form of y is equals to mx plus c. But look at this. We need to first find the gradient of what? The gradient of that AC. Let's work on this. So the gradient of AC is equals to y2 minus y1 over x2 minus x1. So now let's look at this. I have A, and the coordinates of A is 4 and 2, and I have the coordinates of C, which is minus 6 and 7. So from these coordinates, tell me which one is the first one. It's A, so this will be your x1, y1. This will be your x2, y2. So now you can see that when you name your points, there's no way you're going to make mistakes when you do the substitution. Okay, let's work on this. What is the gradient of AC if we substitute? So the gradient of AC, it's equals to y2, it's 7, minus y1, which is 2. So the top part, we can see that we're going to have 5, okay, divide by your x2, which is minus 6. Remember, we are looking at these points, okay? So this will be minus 6, and what is my x1 is just 4, so we're going to minus 4. Okay, so now when I work this on the calculator, what is this equals to? The top part is 5, the bottom part is minus 10, which gives us minus 1 over 2. So the gradient is negative 1 over 2. So now I can say that since the gradient of AC is minus 1 over 2, we can write the equation as y is equals to minus 1 over 2x plus c. Okay, so let's do this. Let's try to find the value of c. We can use one point between these 2 points. So I'm just going to use A. I'm going to substitute A. Look at this A. I know that my y is 2. So where there's y, I'm going to put 2. Then this is minus 1 over 2 into where there's x, we need to put 4 to find the value of c. Okay, so now I hope, guys, you are not confused because of this too much. We don't have much space, as you can see, so it's fine. So now when I look at this, minus 1 over 2 times 4 is just negative 2. So the negative 2 will come to the other side to be positive 2. So it will be 2 plus 2, which will give us the value of 6 as the value of C as 4. So what will be the equation of that AC? So AC will have the equation y is equals to, remember we need to substitute the value of C as 4, which will be minus 1 over 2x plus 4. I hope everyone understands how we got that value. Now we are about to go to the final part of this problem. So now that we have the two equations, we need to equate. So we need to take that given equation, which is this one here. We need to take the 2x plus 3, equate that to the minus 1 over 2x plus 4. Then we need to group the like terms. When you group the like terms, the minus 1 over 2 will come to the other side. Okay, so it will be 2x plus 1 over 2. So when we add the 2, if I have, what is this? If I have 2x, if let me quickly verify this, it's 2x, which will give us this will be 2x plus 1 over 2x, it's equals to 4, and then from the 4 we need to minus what? From the 4 we need to minus the 3. Okay, so let's hope this, what we are doing here, it's right, né? So now I'm going to say 2x plus 1 over 2. What is that equals to? What do we get? I'm still punching this on the calculator. 2 plus okay, so the 2 plus 1 over 2, this gives me this will be 2 times 2 which is 4 plus 1 is 5. So this is 5 over 2x, and we're going to equate this to 1. So we need to make x subject of the formula. So when you solve this, the top part is 5x, it's equals to 2. Therefore, what is x? X is just 2 over 5. That's the value of x. So the coordinates of d, the coordinates of d there, the x coordinate of d is just 2 over 5. I'm not sure where can we work this other problem. Let's move this somewhere up here. Maybe we can finish the problem somewhere here. I'm very sorry, guys. On our next lesson, we'll make sure that we have enough space. Okay, so now that we have this, x is equal to 2 over 5. What I'm going to do now, I need to substitute this in one of the equation to find the corresponding y value. So I can use the equation y is equal to 2x plus 3. So meaning that where there's x, we need to put 2 over 5 plus 3. Then what is the y value? It's 2 times 2, which is 4 over 5 plus 3. So if it's 4 over 5 plus 3, we can say 3 times 5 is 15, plus 4 it's going to be 19. The answer is 19 over 5. You can also verify that on your calculator. Therefore, the coordinates of d will be 2 over 5, which is the x value, and 19 over 5. I'm very sorry, guys, about the space. We don't even have the space to work on the last problem, which is the area. So I'm just gonna be very fast on this one. Maybe we can answer it up somewhere up here and say this is my 4.4. They want us to find the area of triangle OBF. Let me quickly highlight that area, that triangle O. We start from O, okay, all the way to B. Guys, I think you can see how easy the question is now. So now this will be my height, right? So remember, we can use the formula that say area is equals to half base times the height. I was going to also show you how to use the sine rule formula, but we don't have much space, so I'll just go with the easy question. So now what is my base, guys? Look at this. I can create a base of that triangle. I can do a construction. So when I do the construction, my base is 2. Why? Because look at this. The x value of b here is -2. But remember, we are looking for the length. For the length of what? Of the base is just 2. So this tells me that this will be half base, which is 2. We need to find the height. The height is this part. Please don't make mistake on this one. The height is this part. We just need to know what is this point here, which is the y-intercept of this equation. We find the y-intercept if x is 0. Can you see that where there's x, if you put 0, you're going to get that your y-intercept is 3. So this will make the height to be 3. So the height from 0 to that point is 3. So this will be multiplied by 3. Therefore, what is the area? So the area is just positive 3 if you put that on the calculator. So please make sure that you say 3 units squared to show that you are referring to the area. 3 units squared. So now I was positive that all the answers will fit on this, but please, guys, just make sure that you follow through each and everything that we did. You can even go back to the lesson and pause, work out on some of the questions step by step. Yeah, so on our next lesson, let's make sure that we have enough space to solve the problems and also work out on other methods. Remember, on this problem I had another method that I wanted to show you how to find the equation, but because of the space, even here there's a sine rule method that we can use to answer 4.4. But that's it for this lesson. If you understand the lesson, if you enjoyed the lesson, please make sure that you hit the subscription button and join the family so that we'll make sure that you feel at home. Okay, grade 12s, let me teach you how to be the best when it comes into answering this type of questions. So, welcome to the channel. We're going to work on question 7 and math paper 2, and this is the September 2020 file exam. Right. So, looking at this question, they say in the diagram PQ and R are 3 points in the same horizontal plane, and PR is equals to QR, which is equals to M. Let me go and write that on the diagram, because I can see that on the diagram this side is equals to that side, which makes this part here to also be M. I hope you can see that one. QPR it's X, we can see that. So if QPR is X, if this angle is X, this angle also is X. Remember, base angles of a triangle. So I'm going to say angle Q1 is equal to X. What is the reason? You can say opposite, what is this? Opposite side equal angle, or you can say base angles of a triangle. Okay, so if I have a triangle like this, and this side is equal to that side, this angle is equal to this angle, base angles of a triangle, right? So now what I'm going to do next, let me see what they say on the statement. SP is perpendicular to PQ. So SP is perpendicular to PQ. This is 90. So I'm going to indicate that by 90. The angle of elevation of X from Q is Y. We can see that from the diagram. Now, can we please answer the questions? The first question says for 5 marks. Wow. Express the area of triangle PQR. The area of triangle PQR in terms of X and M. Okay, so I want to teach you how to answer this type of questions by following what the question is saying. So when they say express the area in terms of X and M, so in your answer you should have X and M. Okay, so the area of what? Triangle PQR. Let's go and highlight that triangle that they are referring to. P, Q, R. That's the triangle that we need to focus on. And when you answer this, you need to tell the marker which triangle are you working on. So for this 7.1, I'm going to tell the marker that in triangle PQR, remember the area of a certain triangle. You first have to go to your formula sheet and read. Let me check if we do have the area, the formula for area on the formula sheet. Okay, there it is. Look at this. The area of a certain triangle, it's half AB times the sine of angle C. So I'm going to teach you how this formula works. Okay, so you see this AB, it should be the two given sides. So it should be this side and that side. So this is my A, this is my B. So this C is the angle that is between that A and B. So angle C, it should be the included angle. Okay, so let me go back to my triangle and see what I have. Then I need to write down the correct formula. So now I have M, which is this side, that's M, and then I also have this side here, it's M. So these are the only two sides that are given. So I am forced to use this angle. So when I calculate the area, I'm going to say the area is small p. This side here, it will be small p, and this side here, it will be small q. Okay, because this side is the one that is opposite to that one. So I'm looking at this angle here. The angle is opposite to that, so it's going to be small q, and then this angle is opposite to that side, and that will be small p. I hope you understand how I got that. So to find the area, I'm going to say the area of that triangle PQR, it's equals to half. Then I'm going to write my two sides, which is small p multiplied by q, the sine of that included angle. The angle should be between small p and q, and that angle is what? It's angle R1. So this will be the sine of angle R1. Guys, I think most time there is a mark for the formula, but make sure that you write the correct formula. Even if they don't mark the formula, make sure that you put in the correct formula. Okay, so now I'm going to check. I have P and Q, both of them, those values of the sides, it's M and M. But do I have angle R1? No, I need to first calculate angle R1. How can I calculate angle R1? Using the sum of angles in a triangle. So what I'm trying to say is that if I take this angle, I add it with that angle, and also add it with that angle, I should get what? 180. Therefore, this tells me that angle R1 is equals to 180. I minus the sum of these two angles, which is x plus x, that gives me 2x. So that is angle R. So this will be 180 minus 2x. Okay, so now that you have angle R, let's go and write this. Please, when you do this, when you answer a question, try to also give them reasons. Say that the reason for this one is going to be, the reason is going to be sum of angles in a triangle. Angles in a triangle. So let's just do the substitution on that formula. So this will be area. The area will be half small p, it's m, multiplied by m, then the sine of 180 minus 2x. So I know that already you are asking, how can we solve this type of question? Don't stress. This will be half m times m, that's m squared. Then the sine of 180 minus theta. Where is 180 minus theta? That's in second quadrant. How is sine in second quadrant? Sine is positive. So we can reduce that and write it as the sine of that angle. And this is the area. So by writing this, you'll definitely get the full 5 marks. I think here they were just giving away the marks. No? They were just giving away the mark, that 5 marks. So this is how you answer 7.1. Let's move to 7.2. 7.2 says that show that PQ is equals to 2m the cos of x. Okay, so let's assume that you don't have an idea what is the question saying or how to approach this question. So let me give you an idea or the best way that you can use to attack this one. This is very important because this is when trigonometry part 2 starts to be more interesting. When they say show that PQ, you need to go on your diagram, your focus should be on PQ. Look at where's PQ. I'm going to highlight that PQ so that you guys can see where's PQ. Look at the line PQ. Right, so this is my line. And when you look at that line, it's a common line between two triangles. It's a common line between triangle QSP, and it's also a common line on QPR. So this is a common line. So now you need to choose which triangle should I work on to do my proof. This is how you choose. You go to your proof where they say show that we need M and X. So this tells you that the triangle that we should work on is the one that has M and X, which is this triangle. So we're not going to use QPS, but we're going to use QPR. I hope you understand that part. And also tell the marker which triangle you are working on. I hope you understand what I'm trying to do here. So you're going to tell the marker that to answer 7.2 in triangle PQR, okay, then that's when you can start working on that. We can say that this will be the sine root. Okay, so I need to find this side and I need to use the angle opposite to that side, which is angle R. So this will be PQ over the sine of that angle R1. this is equals to, I need to choose the side that has an angle and a side. So both of them, I can use this one and that one, or I can use this one and that one, because these two sides, both of them have angles. So on top of this will be QR. I can use QR over sine of angle P. Okay, let's do the substitution. We are looking for PQ over the sine of angle R. We said this is 180 minus 2x. Then let's equate this to QR. Okay, we know that QR is M. Let's equate that to M over the sine of X. Okay. Right. What should we do now? Simple. Let's make PQ subject of the formula. Let's solve for PQ. You cross multiply. You're going to say PQ. You multiply that by the sine X. I'm going to equate this, but before I do that, can I please reduce this guy here? I want to do the reduction here and reduce this. I know that we said this is the sine of 2x. So since it's the sine of 2x, I'm going to write that as the sine 2x, and then this will be m. When we multiply the 2, this will be m times the sine 2x. Okay, therefore divide both sides by that sine x. Divide both sides by that sine x. What is PQ equals to? PQ is just m, the sine 2x over the sine x. And when I look at this, I don't have what they are looking for. So this tells me that PQ, I have m sine 2x over sine x. So what is that telling you? Simplify further to find the answer that they need. So I need to have 2m, and I also need the cos x. Look at this. I only have sine x. How can I bring cos x? I know that this one is an identity. We can change that into 2 sine x cos x. You see, that's an identity. Let's go and rewrite our equation and see what we have. So this will be PQ. It's equals to, this will be m times 2 the sine x, the cos x, and everything is divided by the sine x. We don't have a denominator here, so this tells you that we need to get rid of the like terms. Okay, we need to take this sine x to cancel the one on bottom. And what do you get? So you can see that therefore PQ is equals to, I will write it in this order. The order they want it as 2m the cos x. Therefore this is the final answer. That was easy, right? That was very easy. Look at the next question. The next question is just only 2 marks. So 2 marks tells you that this is just a friendly match. So let's work on that. Hence means that use whatever answer you got on the previous question to prove that SP is equal to 2m the cos x times y. So when they say hence, on the previous question, hence it's saying that use PQ to prove that SP is 2m. So look at this. They want you to use PQ, which is this side, to find what? Use this side to find SP. So, and this is a right angle triangle. This is my opposite. This is my adjacent. Right. So when I do the proof, I need to have something like the angle Y. So what is that? So according to SOHCAHTOA, I'm going to check. They said I must use QP, which is my adjacent, and I have my opposite. So I'm going to choose the one that has adjacent and opposite, which is tan. So this will be tan of that Y. It's equals to opposite, which is SP, all over hypotenuse, which is QP. Let's go and write that down. The tan of, so this is 7.3. We're going to say the tan of that Y is equal to opposite, which is SP, over adjacent, which is PQ. You just have to substitute what you have. So this will be the tan of Y. This is equal to SP. Remember, we are looking for SP. So I'm going to leave the SP like that and divide this by PQ. which is something that we got as 2m the cos x. So this is what I have. So now, how can I make the SP subject of the formula? Easy. Multiply both sides by that 2m, the cos 2, isolate the SP. So I need to multiply this side by the 2m, the cos x, multiply the other side by the 2m, the cos x. So these two cancel this side. This leaves me with SP to be 2m, the cos x tan y. Then this is proved. Please make sure that you follow the steps. First thing first, look at what the question is saying. And then when you see the word hence, means that use whatever that you got previously to prove that, you see. And that's it. This is how easy the question is. Easy 11 marks. And that's it for this question. So yeah, this is where we're gonna stop for this question, and we'll work on the next question. I'm not sure you can see, but let's go to question 7, which has to do with trigonometry part 2. Look at this question 7. This is something that you will get on Monday on your exam. You see how the question is. They say in the diagram, blah, blah. So most of the time, whatever that is in the statement, they are telling you what you see on the diagram. You understand?
Yes.
Okay, if you can give me a second, let me connect my SP pen, then we'll start.
Sure.
All right. Okay. So I want to look at what they are saying on their first question. The first question of this question 7, question 6. So determine the area. Okay, so the area of triangle XYZ. Tell me, what is the area of triangle XYZ? How this is easy one, Magnet. How can we find the area of triangle XYZ in terms of R, P, and Q? How can we do that? Looking at this diagram, how can we find the area?
In terms of
Talk to me. You know which triangle they're talking about? X, Y, Z.
X, Y, Z, yes, and then they're looking for the area of A, ne?
Yes. So this is my triangle that they are referring to, right? This is the triangle XYZ. And how can we find the area of that triangle in terms of RP and theta?
I think we're gonna say a half, and then the formula of the R times P.
I can't hear you.
I'm saying that where's A first? Because determine A the area of. If Fastani the fra.
Please say that again.
I don't understand which way is A. Or they asking me to determine the angle.
The area of triangle X, Y, Z. And remember, if this is 1 mark, this tells you that the question is very, very easy.
You don't have to use the formula.
Yes, we have to use the formula, but which formula should we use to find the area of triangle XYZ?
It's the one that says a half B times C sine of that angle A.
Exactly. So you just have to go to your question paper. At the back of your question paper, you'll definitely get that formula. Or the area of a triangle. Here is the formula. The area of a triangle is half AB, the sine of C. So it depends. Remember that C is the included angle, right?
Yes.
So I'm just going to check which side I have the angle, and we can see that the angle is 2 theta. So the area in terms of this, it will be half the other two sides, which will be half of P multiplied by R the sine of that included angle, which is 2 theta. That's the area of that one. You see, by looking at the mark allocation, the question is very easy. Then you are done. Number 6.2. Express R in terms of A, P, and Q. They want us to express R. So look at this. Already we know what is the formula, right? Already we know what is the formula. So if I write this down, we know that the area A, it's equals to, okay, they say express R in terms of A, P, and theta. And we just said that the area of that triangle is half of PR, the sine of theta. They want us to make R subject of the formula. So I'm going to divide this side by half P, the sine of theta, divide the other side by half P, the sine of theta. So we can see that if this cancels, R is just A over half P, the sine of theta. That's the answer for 6.2. Okay? Okay, the next one. Hence show that the height of the pole is given by this formula. Hence means that use whatever that you got. Okay? So hence show that, you know, even last time we talked about this. If the question says hence, use what you got. But now focus, put your focus on what they are looking for. They are looking for the height, which is h in this diagram. Okay? They are looking for what? They are looking for the height. And if you look at this, this is the height. Okay?
Yes.
So if they are looking for the height, they said, this is where I need you to be smart when it comes to this. Look at this. Hence show that the height is given by that. And then we need, when they say hence, means that use the answer that you got previously, which is R is equal to something. So the height is a common length of these two triangles, X, Y, L, and also is the common height of L, Y, Z. So we need to choose the triangle that will give us R, because they said hence. You understand what I'm saying?
Okay, yeah.
So the triangle that will go with is this one, so that we can get R. So I have height, or I'm looking for height, and I have R. So this is opposite if I'm using that angle. So this is opposite, and this will be adjacent. So this tells you that to answer this 6.3, we're going to use, for 6.3, we're going to use what we call the tan of that angle, the tan of theta. So this will be the tan of theta is equals to opposite, which is h over r. Then you just have to substitute that r and then solve for theta, and then solve. Let's prove that h is a over p, the cos of theta. You with me there?
Yes, sir.
So I'm just gonna make h subject of the formula here, multiply both sides by r, and this will give us that h is equal to r, the tan of theta. Then I can substitute my r, which was a, over half p, the sine theta, and this is multiplied by the tan of theta. Okay, you're still with me, right?
Yes, sir.
Okay, so I know that the tan of theta, I can write that as, the sine theta over the cos theta. So look at this, the proof, we don't have any sine theta, so we need to get rid of that sine theta. We don't have any sine theta, so I think we are missing something here. This was 2, the sine of 2 theta, so this tells us that r is wrong. So r should be 2 theta, not theta. You see, these are the mistakes that you need to pay attention on. So this is the sine of 2 theta, and then this will be the sine of 2 theta, and this one also will be the sine of 2 theta. You understand why I'm changing that?
Okay, sir, I get it.
Okay. Then when I have this, I need to change this and say h will be equals to a over half of p. I know that sine 2 theta is like saying 2 sine theta, the cos of theta, and this is multiplied by the sine of theta over the cos theta. So we don't have the sine theta. Let's get rid of this sine and that sine. So now what's going on is that we need to multiply whatever that we have left there. So on top, we only need a. So this tells you that on top, on this question, this is just a, and this is over 1 over 2 p, and then this will be 1. Oh, the 2 cancels. Can you see this 2 and that 2 cancel? I'm left with p, the cos theta times cos theta, which is the cos squared theta. Then we did the proof. This is what they were looking for. Can you see?
Yes, sir.
So the most important thing, focus on what they are looking for, which is the height, and then to choose the triangle, you're going to say the hands means that use the answer, meaning that use R to find that height. So I can't go to triangle XYL, but my focus will be on triangle LYZ. Are you happy with that?
Yes, sir.
100%. Let's move to the next question. If h is 20 meter, wow, this was 5 marks. Okay. If h was 20 meter, p is equal to 10 meter and theta is equal to 60. Determine a, the area of that triangle XYZ. So if you still remember, to answer this question, we know that we set the area of this is equals to a. Okay, the area was a. Okay. Wait. Let's make sure that we understand what is the question saying. The question is saying determine a, the area.
Yes, sir.
If they say determine a, the area, look at this. If h is 20, p is 10, theta is 60. I just let me go back. What is the area? The area is half. The area was half p r the sine of 2 theta. Ne? But look, hey, you need to be very careful. Ne? If I use that question, I'll be wrong. If I use this formula, if I substitute here, in fact, I won't be wrong. I don't have R in this statement. Do you understand?
Yes.
I don't have R, so I need to use this 6.3 and make a subject of the formula, because on 6.3, I have H, I have P, and I'm given theta. So I can just say H is equals to A over P, the cos squared theta, and then where there's h, I need to substitute 20. This is equals to a. This is a over p, which was 10, and then the cos squared of 60 degrees. Okay, so this tells me that therefore the area is just 20 multiplied by 10, the cos squared 60. What do you get on your calculator when you calculate? What is the area?
I got 50, but let me recheck. I got 50.
50, and then since this is in meter, it's going to be meter squared. Wow, I think this was the if I get something like this in an exam. Yo. And then determine the length of t. Correct to 2 decimal place. What is t? Do we have t on this equation? We don't have t. What are they looking for?
2 decimal places.
I don't know. Maybe there's some sort of error. Maybe they are looking
I
for.
think they made a mistake.
Yeah, there's no T here. Maybe we are looking for P or R. Ne? We are looking for P or R. Then yeah, you can just work on that. So I think it's best if I just leave it like this because we don't know what is T. Maybe they were supposed to say R. If they want R, we know the formula for R. What was the formula for R? It was A over 1 over 2 sine theta. Ne? So that was R. Then you can just substitute on that. Let's move to the question that I wanted us to do, which was question, let me see how much time we have. Okay, fine, we still have time. I think we can do question, I was interested in question 9, but before we do question 9, I think it's best if we go to the next question. Let's look at question 7. In the diagram below, O is the center of the circle. PQ, SR are the points on the circumference. PQ and QS are equal. And okay, it's fine. We can see that. So determine given reason the size of angle S1. Tell me, looking at the diagram, what will be angle S1 equals to?
Okay, looking at the diagram.
This is my angle S1. What will that angle be equal to? This is grade 11, eh?
Yes, but like I take long with Euclidean geometry. It's like, but I understand that side of SQ and PS is the same, right? And this is not a quadrilateral. It's not a cyclic chord. So this one the opposite word, and this is the chord.
Okay, you know the best thing you can do if you don't know how to answer a question, eh? Look, you need to go back to the statement, look at what are you missing at the statement. But even if you look at the diagram, you need to check where is that angle S1. What is going in? Is it in a triangle? Is it in a semi-segment? What is going on? If it is in a between a tangent, if it's in a triangle, what is going on in that triangle? So now we can see that angle S1 is inside the triangle PQS. What is going on inside that triangle PQS? That's what you need to ask yourself.
Yes, sir, I know what it is.
Okay, so now what is angle S1 equals to?
It's 25.
It's
25.
25.
Yes.
Okay, so let me try and see how you got that 25. Let's see if you got that one right now. So to find angle S1, first thing first, because someone will be marking my script, so I need to make sure that whatever they mark, they understand my work. So I'm going to tell them that these two angles are equal. So I'll tell the marker that angle P1 and angle S1 are equal. Reason, I'm going to say opposite angle, opposite side, or you can say base angles of a triangle, right?
Yes.
Angles opposite equal side. Okay, then I'm going to say therefore, this tells me that I can write this as when I add the two, since they are equal, when I add angle S1 with angle P1 with that angle Q, I need to get 180. Since they are equal, I can let both of these to be X or maybe that angle S1 that we are looking for. So I can say angle S1 plus angle S1 plus Q, it's 180. So this is two of those angle S1. We add, Q is given as 180 degrees, 180, then this will be 2 angle S1. It's 180 minus 180. I think that's 150, eh? 50.
Yes, sir.
Thank you very much. You see, your answer is correct. Therefore, angle S1 will be 25 degrees. Easy. Then let me look at R. Let me look at angle R. Where's angle R? Look at where's angle R. So angle R is an angle in semi-segment with what? So look at this. I'm gonna look at the base that is subtending that angle at a circumference, which is this base. So it gives us that angle there. The very same base gives us angle S1. So these two angles will be equal. So I'm going to say angle R is 25 degrees, reason angle subtended by the same chord.
Yeah.
Okay, so this is angle subtended by same chord. Okay, then O1, what will O1 be equals to? So O1, if I look at this correctly, O1 can be angle at center, but we need to be very careful. It's angle at center for which chord? You understand?
Okay.
So it's going to be angle at center is twice angle at a circumference. Okay? Right.
Yes. Yes.
So now, what I need you to do is that when you apply the angle at center, I'm just going to show you the chord that we need to focus on, because when it's like this, you might be confused on how to apply the angle at center. So look at what I'm going to do. You see this arc here. This arc, which is arc PS. You understand?
Yes.
So this arc, so the arc that I'm talking about is PS, which is this part here. You get it? So it subtends angle O2 at the circumference, not angle O1. I mean, I'm sorry, angle O2 at the center, not angle O1. So angle O2 is the one that is twice angle at the circumference, because the very same arc, it subtends that angle Q. So this tells you that O2 is the one that will be twice angle Q. So now when it's like this tells me that if I can find O2, O2 will be 2 times that 130 degrees, and then reason will be angle at center, angle
angle at center is 2. No, angle at circumference is 2 times the angle at center.
2 times angle at circumference. So now when it's like this, I can say angle O2 is just 260 degrees. So now that you have angle O2, you can see that to find angle O1, we can use a revolutionary angle. We can say that the two angles, when you add them, they should give us 360 revolutionary angle. So therefore, I can say angle O1 plus angle O2, they should give me 360 degrees. O1 is what we are looking for. O2 is 260. 360. So I just have to move the 260 to the other side. This will give me 360 minus 260, which gives us 100 degrees. All good?
Yes, sir.
Okay, just give me a second. I want to look at the next question. In the diagram below, O is the center of the circle. AB is perpendicular to diameter DC. And they say that CM is to MD. The ratio is 2:7. And AB is 14 units. Okay? So now if AB is 14 units, this tells me that AM will be 7, MB will be. You agree with me on that?
Yes.
When I say this side will be equals to that.
Yes.
Okay, let's see what the question saying. If CM is 2x, the length from C to M is 2x. So this is 2x. They say express DC in terms of x. DC. What will be DC in terms of x?
X to diameter.
You need to be very careful about this. We need to be very, very careful about this. So remember that. How can we do this? Remember DC in terms of x. DC is the diameter.
Isn't it 7x? Because didn't they say that CM is to MD? So MD will be 7x, so DC will be add to.
So MD will be what?
Isn't MD gonna be 7x?
Exactly. So the length from M to D, that will be 7x because of the ratio, right? So it will be 7x and then CM is 2. So when you add the 2, what do you get?
It's gonna be 9x.
9x. Thank you very much. And then express OM in terms of x, the length from O to M in terms of x. So remember that OC is 7x, ne? No. OC, yeah. No, OC won't be 7x.
MD will be 7.
Yes, let me write this down. So to express OM in terms of x, we know that the length from O to M will be equals to, we need to take OC, we subtract MC.
Yes.
Is that making sense?
Yes, sir.
So this will be OC. We said OC is the radius now. So OC is the radius, but now look at this. If OC is the radius and we know that DC it's 9, we can take that 9x divided by 2.
By 2, yes.
So this will be 9x over 2, that is OC. Then we subtract MC, which is 2x. Then we can just add these other like terms, ne?
Yes.
So it's like saying 9 over 2 minus 2, which gives us, what do you get when you say 9 over 2 minus 2?
That's going to give you 5 over 2.
5
which is
over
2.5.
2x, which is
2.5x.
2.5x, okay? And then hence or otherwise calculate the length of the radius. Hence or otherwise, meaning that use the answers that you have. They want us to find the length of the radius. So I can find this length here, which is OB. That's my radius. And I know that BM, we said these two lines, they said AB, it's equals to what? 14.
Yes,
Therefore,
8 is equal to 14.
since this is a line drawn from center, it will bisect the chord, meaning that BM, it will be equal to AM, which will be equal to 7. So this one is 7. This is what we are looking for. And then we just got AOM to be 2.5x. So let's use theorem of Pythagoras because this is a 90 degrees. We can use theorem of Pythagoras and say r squared is equals to x squared plus y squared. And then my r is my OB. This is squared. And my x is going to be my BM. This is squared. We add y, which is my OM. And this is also squared. So when I substitute, I'll have my let's substitute OB. What is OB equals to? It was the radius. So the OB and OC are equal, right?
OB and OC are equal, yes, because they are both radius.
Okay. So this tells you that OB will be 9 over 2x. And this should be squared. And then BM, we said this is 2x. So I'm going to say BM, not 2x, 7. So this will be 7 squared plus OM, that's 2.5, which was 5 over 2x squared. So I'm just going to put everything in fractions. So 9 squared, what is 9 squared? 81, ne? And then 2 squared, that's 4. X squared, that's x squared. And then 7 squared, that's 49. Yes. And then we add 5 squared, that's 25. 2 squared, that's 4. Then this is x squared. So I think I can bring this together and add to the like term. I can say this is 81 over, it will be 81 over 4 x squared. Then I subtract 25 over 4 x squared. So this is equals to what? 49, né? So I'm just gonna try and write this as like this. I'm not sure if you'll agree with me. This will be 81x squared minus 25x squared, everything divided by 4. This is equals to 49. What do you get when you say 81 minus 25?
I get, okay, 81 minus 25. I got 56.
56x squared, right?
Yes.
Divide that 56 by 4. Tell me what you get.
I get 14.
14x squared is equal to 49. Then divide both sides by 14. What is x squared equals to?
14. I get 3.5.
Okay, 3.5. What is the square root of that? You're gonna square both sides. What is x equals to?
So I square rooted it, and my decimal form is 1.87.
1.87. So now the question said calculate the length of the radius, and we know that the radius is OC. The radius is the length OC, which is 9 over 2x. So where there's x, we can just substitute that 1.87. Okay. So this will be 9 over 2 into x, which is 1.87. The answer that you get is your radius. Therefore, radius, it's equals to, what is that equals to?
8.42.
You got?
8.42.
8.42 units. 8.42 units. And that's it for this one, isn't it?
Yes, sir.
Okay. I want us to go to the last question, which is question 9 of this question paper. Né?
Okay.
Let's use this 20 minutes to answer question 9. In the figure below, KL is a tangent to a circle. LJ and R are joined on the circle, and MN is parallel to KL. Okay. Then they say that prove that JMR is a cyclic quadrilateral. Prove that triangle JNR is similar to triangle. Okay, let me start with the first one, 9.1. Prove that JMRN. So I'm gonna go and say J. This is my point. Then R. O M R M R N. That's it. You see that one?
Yeah.
So we need to prove that this guy here is a cyclic quad. I'm not sure if you still remember the ways to prove a cyclic quad. Give me one way that we can use to prove that something is a cyclic quad. One way that you remember. What should we do to prove that something is a cyclic quad?
You know that the opposite angles must be equal to 180.
Okay. And what else?
The exterior angle must be equal to the opposite interior angle.
Okay, and what else again?
Give me 1 minute. I'm out.
Both angles in the same segment. Remember we said that if something is a cyclic quad, it will, if I have this and then this arc here, the arc A, B, C, then we have D. If this angle is equal to that angle, therefore this tells you that A, B, C, D is a cyclic quad. So remember, all the points of a cyclic quad, they must be at the circumference. So if you can have two angles subtended by the same arc, then this is a cyclic quad. You understand? So now what we need to do, it's either we prove that this angle is equal to that angle, or we prove that this angle is equal to that angle. Then if we can manage to prove those, then this will be definitely a cyclic quad. Let's try and see what we can do from that. Okay, so I'm going to first say, look at this.
So wait, in a way, was I wrong with what I was saying?
No. You are not wrong. You are correct. If you can find a cyclic, if you can prove that this angle 3 is equal to that, that whole angle, then this is a cyclic quad. You are right. If you can prove that opposite angles are supplementary, then you are also correct. You know?
But it just depends what you are given.
Exactly. It depends on what you have. Né?
Okay, so
you know what I'm going to do? I'm going to mark angles that are equal first, and then we'll take it from there. Né?
Okay, so.
So I see a parallel line there, and this line. So I'm gonna find alternate angles first. This angle, it's equals to that angle. All right, again?
Yes, sir.
And then what else can we see from this? Please help me now.
Okay.
Because most of the angles are outside the circle. Oh, this is a tangent, ne? So what can we say? I see a tangent. I need to find something that I can say about a tangent. So if this is a tangent and this is a chord, so this angle here will be equal to the angle subtended by that chord. So the chord starts from this point. Don't make a mistake. It starts from this point, that point. So it's going to be that 2. Don't say the whole of that angle. You need to be very careful. Né?
Okay, sir.
Right. So now we have angles that are equal. And then what else? Do you see any other angles that are equal?
Wouldn't we have an F, sir?
Don't we have a what?
Like a F angle for fun angle.
Wait, Emily. We are done with the proof. Look at this. Look at this. Look at this. I'm very sorry to disturb you. Né? Look at this. We said that if we can have angles in the same segment, né? Look at this. These two angles are subtended by arc AB, right? They are equal. Then we can conclude and say that these two angles, look at this. The arc RN, it subtend J2 and that L2. Can you see that? And look at this. Angle M is equal to L2. And angle L2 is equal to that J2, meaning that both of angle M are equal. So I think we can just put this in writing. Then we have our answer. Né? So first thing first, we said angle M2 is equals to angle 2. So I think you see that if you can find the angles that are equal, it's easy for you to conclude something. So this will be alternate angles, right? Because MN is parallel to KL. Then we said that angle L2 it's equals to that J2 or
J2.
Okay, so this will be. Then the reason is tan chord, né?
Yes.
Therefore, look at this. M2 and L2, both of them are equals to L2. So M2 and J2, both of them are equal to L2. So this tells you that they are also equal. Therefore, we can conclude and say that M2 and angle that J2, they are equal. Therefore, we can conclude and say J M R N. It's a cyclic. Cyclic quad. And what will be the reason? Angles in the same segment.
Yeah.
Angles in the same segment. And that's it. So let's move to the next question. So 9.2, they want you to prove that J and R, I'm going to highlight that triangle, J and R, ne? J and R, oh, is this triangle here? We need to prove that that triangle is similar to what? That triangle is similar to what? LMK. Okay, LMK. You see K. Oh, this one. So you just have to find angles that are equal in these two triangles, ne?
Yeah, we already have one that is proven.
We only have one pair, ne?
Yeah.
Okay, so the one that we have is that the G2 and the L2 are equal. Reason was tan chord, ne?
Yes.
Okay, so this is 9.2. And then what else can we say? Which other angles are equal?
Let me analyze.
Okay, let's find other angles are equal. Let's see. If we can find one other pair, we'll conclude the third one, ne? Oh, wait, Emerson, listen.
Yes.
Emerson, we just proved that if I look at the problem and you are in an exam, you don't have much time to think about this, ne? We don't have much time. You are in an exam. You don't have enough time to think about this, ne? I need you to pay attention on this one because I see something very interesting here. Look at this, ne? Okay, let me give you a tip, ne? How I got this answer. So I went through back to what we were doing previously and see that how can that information help us. So we just proved that this is a cyclic quad. So if this is a cyclic quad, if this guy here, it's a cyclic quad, you see that part?
Yes.
Already this is proven that it's a cyclic quad. So this tells you that this angle in this triangle, it will be equal to that whole angle, exterior angle of a cyclic quad. You understand? So now I'm going to say that angle M1, it's equals to angle N1 plus angle N2. I'm referring to J angle NR. So they are equal raising exterior. Exactly. Okay. Then therefore we can conclude and say this angle K. We can conclude and say angle K and that angle R. I don't know what is this angle, but we want to call it angle R what? I don't know. Maybe let's say this is R1, this is R2.
R2.
Yeah.
Yes.
So angle R2. Do you know that you are allowed to name your angles in an exam? Because on your answer sheet, they give you this drawing. So when they mark, they look at the drawing if you have named any angles, ne?
Yes, I know.
So this will be, it will be angles of a triangle. The sum of angles of a triangle. Therefore, since we have three angles that are equal, we can conclude and say, therefore, that J and R, it's similar, triangle J and R is similar to triangle LMK. All good, ne?